Sir, streaming has started.
Okay, thank you, sir. Thanks. ഒരു മിനിറ്റ് ഞാൻ റെക്കോർഡിംഗ് ഒന്ന് കൊടുക്കട്ടെ. റെക്കോർഡിംഗ് ഓൺ ആവുന്നേ ഉള്ളൂ. 10 സെക്കൻഡ്. ഓക്കെ. Good morning, everyone. Welcome all you to our initiation online industry interaction for mechanical engineering students. We had started this sequence on 12th October, and we will be having the final session on 23rd October. And this initiation is a joint attempt on the behalf of Department of Mechanical Engineering in Government Polytechnic College, Perinthalmanna, and Government Polytechnic College, Chelakkara. So far, we have seen 5 sessions. We started with the project-oriented session, how to select projects, how to develop such innovative projects into startups, and then we seen a very important session of the role of MSME in Industry 4.0. Then we had an interaction with Dr. Galit, Managing Director of Goodbye Soaps and Cosmetics Private Limited on plant management. Then we had another sequence in terms of design and analysis, applied mechanics and design. It was done by our Nishad sir. Then yesterday we had a peripheral view of fibers in an industry. Today our session is session number 6, exactly the halfway of our program, and we are very privileged to have the guest of the day, a very eminent personality from Indira Gandhi Centre for Atomic Research, Kalpakkam. And on the behalf of all the participants and on the behalf of both the colleges, I would like to extend our humble greetings, and I would like to welcome Mr. SAJISH S.D, the head of Structural Dynamics section in Indira Gandhi Centre for Atomic Research, Kalpakkam. SAJISH sir, warm welcome to you, sir.
Thank you very much for a nice introduction.
Okay, sir. Thank you.
I am Sajish from Indira Gandhi Centre for Atomic Research, Kalpakkam. First of all, I would like to thank the organizers of this program for giving me an opportunity to interact with the students of both Polytechnic College from Chelakkara and Polytechnic College from Perinthalmanna. I would like to thank my college mate and classmate and my roommate, Mr. Pradeep.
Sajish, one minute. Actually, Mr. Sajish has not completed his present introduction. Okay.
Okay. No problem, sir. And I would like to. Yes, sir. Yes. Thank you, sir. Thank you, sir. I would like to welcome all the participants. Both students and faculty are available in our Google Meet and on YouTube live streaming. A warm welcome to all. And I would like to invite Pradeep M, principal in charge of Government Polytechnic College, Perinthalmanna, and the coordinator of this program, to give a further introduction to our eminent resource person and an introduction to the topic of the day. Pradeep sir, now it's on to you, sir.
Okay. Good morning, dear Sajish and Sajid sir, Vishnu sir, and my dear students. Actually, we had started our program on 12th, hosted by Sri Sajid sir. Mr. Sajish is my classmate, batchmate, roommate, and ഞങ്ങളൊരു റൂം എഞ്ചിനീയറിംഗ് കോളേജിൽ ഹോസ്റ്റൽ റൂംമേറ്റ്സും കൂടിയാണ് ഞങ്ങൾ. ആക്ച്വലി ഇപ്പോൾ സജീഷൊക്കെ അന്ന് തന്നെ പഠിക്കുന്ന കൂട്ടത്തിലുള്ളവരും ഞങ്ങൾ പഠിത്തത്തോടൊപ്പം എല്ലാ ആക്ടിവിറ്റീസും ഉള്ളൊരു ആളായിരുന്നു ഞാൻ. അപ്പം കുറച്ച് അത്തരത്തില് നമ്മുടെ ബാച്ചിൽ തന്നെ 3 മൈ കൊളീഗ്സ് 3 പേരുണ്ടെന്നു അല്ലേ, വിനോദും വേറെ 2 പേരും. അപ്പൊ അങ്ങനെ 3 പേരാണ് ഇപ്പൊ കൽപ്പാക്കത്ത് വർക്ക് ചെയ്യുന്നത്. ആൻഡ് വാട്ട് ഈസ് ദ ഇമ്പോർട്ടൻസ് ഓഫ് ദിസ് ടോപ്പിക് ഈസ് ആക്ച്വലി വി ആർ ലേണിംഗ് thermodynamics, power plant engineering, and fluid mechanics, and everything. Something related to thermal related subjects are we are learning. Excellent ആയി പഠിച്ച് അതേ സെക്ടറിൽ വർക്ക് ചെയ്യുന്ന ആൾക്കാരാണ്. നമുക്കറിയാം കഴിഞ്ഞ last few days we have taken the same procedure, and the coming days also we are focusing on our subject and the expertise persons in that subject എന്നുള്ള രീതിയിലാണ് നമ്മൾ കൊണ്ടുവന്നിട്ടുള്ളത്. അപ്പം ആക്ച്വലി സജീഷ് ഈസ് തെർമൽ റിലേറ്റഡ് ആയിട്ടുള്ള ആക്ടിവിറ്റി അല്ലെങ്കിൽ പവർ പ്ലാന്റ് റിലേറ്റഡ് ആയിട്ടുള്ള ആക്ടിവിറ്റിയിൽ വർക്ക് ചെയ്യുന്നതാണ്. തെർമൽ പവർ കോർപ്പറേഷൻ കൽപ്പാക്കത്തിലാണ് സജീഷ് വർക്ക് ചെയ്യുന്നത്. അപ്പം നമ്മുടെ തെർമോഡൈനാമിക്സിന്റെ ഇമ്പോർട്ടൻസ് അല്ലെങ്കിൽ തെർമൽ എഞ്ചിനീയറിംഗിൽ ഇൻട്രസ്റ്റ് ആയിട്ടുള്ള കുട്ടികൾക്ക് ഏത് രീതിയിൽ പോകാം എന്നുള്ളതാണ് നമ്മൾ ഇന്നത്തെ ഒരു സെഷനിൽ ബേസിക്കലി ഉദ്ദേശിക്കുന്നത്. അതേസമയം നിഷാദ് ആൾസോ മൈ കൊളീഗ്. നിഷാദിന്റെ ലാസ്റ്റ് ഡേ ക്ലാസ് ഉണ്ടായിരുന്നത് അദ്ദേഹം എടുത്തത് അപ്ലൈഡ് മെക്കാനിക്സ് ആൻഡ് ഡിസൈൻ എന്നുള്ള രീതിയിലായിരുന്നു. അപ്ലൈഡ് സയൻസും ഡിസൈനിങ് എന്നുള്ള രീതിയിലായിരുന്നു അദ്ദേഹം എടുത്തത്. ഇത് നമ്മൾ വേറൊരു റിലേറ്റ്. ഇപ്പൊ നമ്മുടെ കേരളത്തിൽ തന്നെ കായംകുളം തെർമൽ പവർ കോർപ്പറേഷൻ ഇസ് ദയർ. എനർജി നമുക്ക് ഏതെല്ലാം എനർജി സോഴ്സസ്, ഇതിന്റെ ഇമ്പോർട്ടൻസ് ഓഫ് എനർജി സോഴ്സസ്, ഇലക്ട്രിസിറ്റിയെ പോലെ തന്നെ ഏത് രീതിയിലാണ് ന്യൂക്ലിയർ പവർ പ്ലാന്റ്സ് നമുക്ക് പൊതുജനങ്ങൾക്ക് സാധാരണക്കാരന് യൂസ്ഫുൾ ആവുന്നത് എന്നുള്ളതാണ്. ഇതെല്ലാം നമുക്ക് അന്യം കയറാത്ത സ്ഥലങ്ങളൊന്നുമല്ല. ഞാൻ പറഞ്ഞു വന്നത് നമുക്ക് എത്തിപ്പിടിക്കാൻ പറ്റാത്ത സ്ഥലങ്ങളൊന്നുമല്ല. ഇപ്പം എല്ലാം എഞ്ചിനീയേഴ്സിന് മാത്രമുള്ള ജോലികളല്ല എന്ന് പറയുന്നത് പോലെ തന്നെയാണ് ഡിപ്ലോമക്കാർക്കും ഇതിനകത്തെല്ലാം ഓരോ പോക്കറ്റ്സ് ഉണ്ട് എന്നുള്ളത് സജീഷ് സാർ നിങ്ങൾക്ക് പറഞ്ഞായിരുന്നു. അപ്പൊ നമ്മൾ കേൾക്കുന്ന കാര്യങ്ങൾ VSSC എടുത്താൽ അവിടെ കുറെ എഞ്ചിനീയേഴ്സ് ഉണ്ട് എന്ന് മാത്രമേ നമ്മൾ കേൾക്കുന്നുള്ളൂ. പക്ഷെ സയന്റിസ്റ്റ് ഉണ്ടെന്ന് നമ്മൾ കേൾക്കുന്നുള്ളൂ. ബട്ട് ലോട്ട് ഓഫ് അതർ ഫാക്കൽറ്റീസ് ആർ വർക്കിംഗ് ദെയർ based on their qualification like ITI, diploma, some other technical ക്വാളിഫിക്കേഷൻ ഉള്ളവർ വരെ അവിടെ വർക്ക് ചെയ്യുന്നുണ്ട്. സോ നമുക്കെല്ലാം ഓപ്പർച്യൂണിറ്റി ഉണ്ട്. ഇഫ് യു ആർ നോട്ട് കണ്ടിന്യൂയിങ് ഇൻ യുവർ എഡ്യൂക്കേഷൻ ടു ദ ഹയർ ലെവൽ, യു ക്യാൻ ആൾസോ ഗോ ഫോർ ന്യൂക്ലിയർ പവർ പ്ലാന്റ്സ്, VSSC, റെയിൽവേ, എല്ലായിടത്തും നമുക്കും കൂടെ പോകാൻ പറ്റുന്ന സാഹചര്യമുണ്ട്. അപ്പം ഡിപ്ലോമ ഈസ് നോട്ട് എ ബാഡ് തിങ്. ഡിപ്ലോമ കൊണ്ട് പല ഒരു ജോലിയിൽ കയറിയതിന് ശേഷം വി ക്യാൻ അക്വയർ ഹയർ ക്വാളിഫിക്കേഷൻ. അതിനുള്ള ഫെസിലിറ്റീസും ദേ വിൽ പ്രൊവൈഡ് എന്നുള്ളതാണ്. ഇന്നത്തെ സാഹചര്യത്തിൽ ഏത് ജോലിയിൽ കയറിയാലും ആ ജോലിയിൽ മര്യാദ നല്ലൊരു ഫേമിലാണ് വർക്ക് ചെയ്യണമെങ്കിൽ യു വിൽ ഗെറ്റ് എ ചാൻസ് ടു ഗോ ഫോർ എ ഹയർ എഡ്യൂക്കേഷൻ. സോ എഡ്യൂക്കേഷൻ ഈസ് ഓൾവേസ് ഗുഡ്. സജീഷ് ആൾസോ ഡൂയിങ് PhD, ബട്ട് ഡ്യൂ ടു സം വർക്കിംഗ് പ്രഗ്നൻസി എന്ന് പറഞ്ഞാൽ നമുക്ക് പറയാം. അദ്ദേഹത്തിന് ഇപ്പം കുറച്ച് ദിവസമായിട്ട് അത് ഹോൾഡ് ചെയ്തിരിക്കുകയാണ്. അപ്പം എല്ലാവരും ആ ഒരു ഫീൽഡിൽ എത്തുമ്പം അതിൻ്റെതായ നെക്സ്റ്റ് ലെവലിലേക്ക് പോകേണ്ട ഒരു സാഹചര്യമാണുള്ളത്. അപ്പം ഡിയർ സ്റ്റുഡൻസ്, ഹിയർ ഐ എം ഫോക്കസിങ് ഈസ് യു ഹാവ് ടു ആസ്ക് ക്വസ്റ്റ്യൻസ്. ദെൻ ഓൺലി ദ ഇൻട്രാക്ഷൻ, അവർ ഓൺലൈൻ ഇൻട്രാക്ഷൻ എന്നാണ് നമ്മുടെ അല്ലേ, ഓൺലൈൻ ഇൻട്രാക്ഷൻ എന്നാണ്. അത് സക്സസ് ആവണമെന്നുണ്ടെങ്കിൽ നിങ്ങളുടെയും കൂടെ ഇൻട്രാക്ഷൻ ഉണ്ടാവണം. തീർച്ചയായിട്ടും നിങ്ങളുടെ ഭാഗത്ത് നിന്ന് ഉണ്ടാവും എന്നുള്ള പ്രതീക്ഷിക്കുന്നു. സോ താങ്ക് യു സജിത് സാർ, താങ്ക് യു സജീഷ്. വൺസ് അഗൈൻ നമ്മൾ കുറെ കാലത്തിന് ശേഷം വീണ്ടും ഓൺലൈനിലാണ് കാണുന്നത്. ആഫ്റ്റർ 97 ഒരു പ്രാവശ്യമാണ് നമ്മൾ കണ്ടിട്ടുള്ളത് കൂടെ. അതിനുശേഷം ഇന്നാണ് ഗെറ്റ് ടുഗദർ ഒരു പ്രാവശ്യം അറേഞ്ച് ചെയ്തത്. അപ്പം അതിനുശേഷം ഞങ്ങള് കണ്ടിട്ടില്ല. വല്ലപ്പോഴും ഉള്ള ഒരു കോണ്ടാക്ട്സ് മാത്രമേ ഉള്ളൂ. അതും റെയർ ആയിട്ടുള്ള ഒരു കോണ്ടാക്ട്സ് ആണ്. പക്ഷെ പറഞ്ഞ ഉടനെ എടാ നന്നായി നീ ഇങ്ങനെ അറേഞ്ച് ചെയ്ത് എനിക്കും വളരെ ആഗ്രഹമുണ്ടെന്ന് സജീഷ് പറഞ്ഞപ്പം എനിക്ക് വളരെ സന്തോഷം തോന്നി. കാരണം ഒരു കാര്യം ഡിനേ ചെയ്യല്ല വേണ്ടത്. നമ്മള് എന്ത് കുട്ടികൾക്ക് കൊടുക്കാൻ സാധിക്കും എന്നുള്ളതിനെ കുറിച്ച് ആഗ്രഹിക്കുന്ന ഒരുപാട് ആൾക്കാരുണ്ട്. നമ്മുടെ നോളജ് ഷെയറിംഗ് ആണ് അതിനകത്ത് ഏറ്റവും വലുത്. അതിനകത്ത് നോളജ് ഷെയർ ചെയ്യുന്നതുകൊണ്ട് ഇപ്പം നേരത്തെ പറഞ്ഞു, സജീഷ് സൂചിപ്പിച്ചു, കുട്ടികൾ ചിലപ്പോൾ ക്വസ്റ്റ്യൻ ചോദിക്കുമ്പോഴായിരിക്കും നമ്മൾ പല കാര്യങ്ങളും മാറ്റി വെച്ചിരുന്നത് ഒന്നുകൂടെ തട്ടിക്കൂട്ടി. അപ്പൊ അതാണ് അവിടുത്തെ സജീഷിൽ കാണുന്ന ഒരു പോസിറ്റീവ് സൈഡ് എന്ന് പറയുന്നത്. അതാണ് എനിക്കും കുറച്ച് പഠിക്കാനുണ്ട് എന്ന് ചിന്തിക്കുന്നത്. കുട്ടികളിൽ നിന്ന് പഠിക്കാൻ എനിക്കുണ്ട്. അത് തന്നെയാണ് ഞാനും പറയാറ്. എനിക്ക് അറിയുന്നതിനേക്കാൾ കൂടുതൽ ചില കാര്യങ്ങളിൽ അല്ലെങ്കിൽ ഒരുപാട് കാര്യങ്ങളിൽ കുട്ടികൾക്ക് അറിയാം. ചില സബ്ജക്റ്റുകൾ മാത്രമേ എനിക്ക് അറിയുള്ളൂ എന്നുള്ളത് മാത്രമാണ് കുട്ടികളിൽ നിന്നുള്ള വ്യത്യസ്തനാക്കുന്ന ടീച്ചേഴ്സ് എന്ന നിലയ്ക്ക് എന്നെ. അപ്പൊ ഞാനത് കുട്ടികളടുത്തും പറയാറുണ്ട്. അപ്പൊ കുട്ടികൾക്ക് ഒരുപാട് കഴിവുള്ള കുട്ടികളാണ്. അതുകൊണ്ടാണ് എനിക്ക് വിഷമം തോന്നുന്നത് അവരെന്തുകൊണ്ട് ഇന്ററാക്ട് ചെയ്യുന്നില്ല എന്നുള്ളത്. സോ ഞാൻ ദീർഘിപ്പിക്കുകയല്ല. സജീഷ് അങ്ങനെ അത്തരത്തില് ഇത്രയും തിരക്കുള്ള ഒരു സമയം നമ്മൾ ടൈം ഷെഡ്യൂള് മൺഡേ ടു ഫ്രൈഡേ കൽപ്പാക്കത്ത് വർക്ക് ചെയ്യുന്നു. ആ കൂടെ കിട്ടുന്ന ഒരു സമയമാണ് ഫാമിലി ആയിട്ട് ചെലവഴിക്കാൻ കിട്ടുന്ന ഒരു സമയമാണ് സാറ്റർഡേ സൺഡേ എന്ന് പറയുന്നത്. ഒരുപാട് തിരക്കുണ്ടാകും, ഹോംവർക്കുകൾ ഉണ്ടാകും ഒഫീഷ്യൽ. എന്നാലും ഇത്തരത്തിലേക്ക് നമ്മുടെ ഒരു പ്രോഗ്രാമിലേക്ക് നമ്മുടെ സ്റ്റുഡൻസിനെ അഡ്രസ് ചെയ്യാൻ വേണ്ടി കിട്ടിയ ഒരു അവസരം യൂട്ടിലൈസ് ചെയ്യാൻ വേണ്ടി ഞങ്ങൾക്കും കൂടെ ഒരു അവസരം തന്നതിനകത്ത് നന്ദിയുണ്ട്. വ്യക്തിപരമായിട്ട് നന്ദി അറിയിക്കുകയാണ്. താങ്ക് യു വെരി മച്ച്. താങ്ക് യു സജിത് സർ.
Sajish sir, request to have the grace our students and faculty with your session, sir. Please, sir.
Yeah, thank you very much. Thank you, Mr. Pradeep and Vishnu, Sajit and Vishnu and other faculty members of Government Polytechnic Perinthalmanna and Chelakkara for giving me an opportunity to present or interact with the students of both Polytechnic. For this, I am very grateful to my friend and my college mate, Mr. Pradeep, who called me and told me I am giving you an opportunity to interact. So as he told, I readily accepted that invitation because it's a good occasion to interact with the students. As I was telling to him earlier, that sometimes the questions asked by the students will make us to think more deep on that subject. Sometimes we may be thinking in peripheral way, but when somebody asks some question on some subject, then only we will be thinking how we can answer that in a more perfect way. For that, we may have to read some more, or we may have to brush up our knowledge again. That means we at that time only will understand our knowledge is not complete. So this type of interaction program not only benefits students, it will benefit the person who is taking this or presenting some to the students also. That is the advantage of this interactive program. Thanks to COVID on that aspect, we got some opportunity like this. Otherwise, this way of interaction would not have been, people might not have thought in this aspect. So in that way, we should be thankful to the COVID pandemic in that way, even though it is giving a lot of other difficulties to the people. So with that, first I would like to say a very warm welcome to this my session. And very good morning to the students of Government Polytechnic College Chelakkara and Perinthalmanna for giving me an opportunity to interact with you. And a warm welcome to the staff members of both institutes. I am Sajish, working in Indira Gandhi Centre for Atomic Research, Kalpakkam. In the design of nuclear power plants, I am working in this area for the past 20 years. I am from Kerala. I did my BTech from NSS College of Engineering, Palakkad, along with the head of the Department of Perinthalmanna Polytechnic, Mr. Pradeep. So with this small introduction, I will go to my presentation. I hope you can see my screen. Screen visible or not? Hello.
Sir, yet to.
Screen visible?
Waiting.
Sir, I think sir has to do present no once again.
Oh, okay. Oh, I think I have switched off that. Okay.
Yes, sir. Now it's visible, sir.
Visible?
Yes, sir. Yes.
So today our interactive topic is
kindly remove that bottom bar, sir. Please press hide, sir. Hide.
hide.
In that information. Yes, sir. Yes, sir. Thank you, sir. Thank you very much.
Okay. My video also visible? I don't know. I am not getting any feeling.
Sir, visible, sir. Visible.
Okay. So today our topic of interaction topic is introduction to power plant engineering. And as my friend suggested, I have to give some introduction of what is the role of mechanical engineers in this, especially thermal and nuclear power plants. Even though I am working in nuclear power plants, it is common for both the thermal power plants and nuclear power plants. What is the basic roles of mechanical?
നെറ്റ് ഇഷ്യൂ ഉണ്ടോ മാഷേ?
Maybe it will come, sir.
സജീഷ് സ്ട്രക്ക് ആയിട്ടുണ്ട്. നെറ്റ്വർക്ക് പ്രോബ്ലം ഉണ്ടോ?
സാർ ഒന്ന് കോൾ ചെയ്താൽ മതി.
ഞാൻ കോൾ ചെയ്തോണ്ടിരിക്കുക, പോകുന്നില്ല. ചിലപ്പോ അറിയുന്നുണ്ടാവില്ല സജീഷ് അല്ലേ?
അതെ സാർ, അതെ.
ഓക്കെ. ഇതിനകത്ത് ചാറ്റ് ബോക്സിൽ ഇട്ടാലോ?
അദ്ദേഹം മീറ്റിംഗിൽ നിന്ന് ലെഫ്റ്റ് ആയിട്ടുണ്ട്. രണ്ട് സ്റ്റുഡൻസ് ഒന്ന് ലെഫ്റ്റ് ആവുമോ? അപ്പോഴാണ് സാറിന് തിരിച്ച് ഇൻഡക്റ്റ് ആവാൻ പറ്റുള്ളൂ. നമുക്ക് അത് കഴിഞ്ഞിട്ട് വീണ്ടും കയറാം കേട്ടോ. ഓക്കെ, താങ്ക് യു. പാർട്ടിസിപ്പൻസ് ഒന്ന് വെയിറ്റ് ചെയ്യണേ. സജീഷ് സാറിന് അവിടെ നെറ്റ്വർക്ക് പ്രോബ്ലം ആണ്, തിരിച്ച് വരുന്നുണ്ട് കേട്ടോ.
Okay. ഓക്കെ, അപ്പൊ ഞാൻ കട്ടാകുമ്പോൾ വിളിച്ചാൽ മതി. എനിക്ക് ഇവിടെ ഒരു ഫീലിംഗ് കിട്ടുന്നില്ലേ? ഓ ഇപ്പൊ കിട്ടുന്നുണ്ടോ?
സാർ വന്നു സാർ, സാറിന് കാണാം. ഓക്കെ.
ഫസ്റ്റ് സ്ലൈഡ് തുടങ്ങിയപ്പോ തന്നെ കട്ടായതോ?
സാർ ഇൻട്രൊഡക്ഷനിൽ തന്നെ നിന്നിരുന്നു സാർ.
ഓക്കെ ഓക്കെ ഓക്കെ. ഹലോ, വരുന്നു. ലാഗാകുന്നുണ്ടോ തോന്നല്ലേ? നോക്കട്ടെ. സ്റ്റോപ്പ്. വീഡിയോ കട്ട് ഓഫ് ചെയ്യേണ്ടി വരും. വരുന്നുണ്ടോ?
സജീഷ് സാറേ,
ഹലോ.
പ്രസന്റേഷൻ ഓക്കെയാണ് സാർ. സാർ ആ പവർ പോയിന്റ് ഒന്ന് ക്ലിക്ക്. യെസ് സർ.
ഓക്കെ, ഓക്കെ
ഓക്കെയാണ് സാർ.
ഓക്കെ. അപ്പൊ എന്തെങ്കിലും കട്ട് ഉണ്ടെങ്കിൽ അവിടെ ഫോൺ ചെയ്താൽ മതി. ഓക്കെ, ഞാനില്ല, അത് ഫസ്റ്റ് സ്ലൈഡ് തന്നെ, ഞാൻ അവിടെ നിന്ന് പോയിട്ടില്ല. ഓക്കെ ഓക്കെ ഓഹോ ഓക്കെ ഓക്കെ ഓക്കെ. So welcome back. Sorry for interruption.
Information bar ഒന്ന് ഹൈഡ് ചെയ്യൂ സർ. അപ്പോ താങ്ക് യു സർ.
ഓക്കെ. എന്തെങ്കിലും ബ്ലോക്ക് ഉണ്ടെങ്കിൽ അത് പറഞ്ഞാൽ മതി. ജസ്റ്റ് sound.
Thank you.
Okay. So what I was telling is what is power plant engineering. I don't know how much people might have heard, so I will just repeat it again. Somebody already hearing, maybe a repetition. Anyway, what I want to convey that this power plant engineering encompasses various disciplines. As I told, it includes mechanical engineering, electrical engineering, instrumentation engineering, computer science, almost whatever field you name, that all these people have an opportunity in power plant. So this power plant engineering includes the starting from the design of a power plant, fabricating various components, construction, testing of the components after construction and installation. That means entire commissioning of the power plant, then operating the power plant, then maintenance, and finally the decommissioning. So all this operation basically comes under power plant engineering. So all this operation involves expertise from various disciplines such as mechanical engineering, electrical engineering, instrumentation engineering, civil engineering, computer science engineering. Almost all the fields are required for the successful operation of a power plant, starting from design to from the decommissioning. So as I told, it may be a diploma holding a person or a BTech or any other higher expertise. You have a chance in the power plant industry. So as I told, can you hear? Hello?
Yes,
Hello?
sir. Yes, sir. Perfectly audible.
Okay. Because okay, I'm not. Okay. So that means if you have an expertise in any of these areas, you are most wanted in this industry. So you have to have a very good in-depth knowledge in your basic subjects. That is the one we are looking for when we recruit a person to this industry. So because first when you come as a fresher, people don't know anything about you. Suppose you have an experienced person, we will be testing your experience on that particular subject or that particular area. So your expertise will be tested. But when you come out as a fresher, that means we don't have any tool to test these people. So what we are looking for is how much he knows about his subjects. That's what you have to be very thorough in your subjects. You may be thinking, so many subjects I have studied. I may be working only in one field. But as a fresher, you don't know which area you will be going. Okay, you may have some preferences, but still, a person who is recruiting you or interviewing you, he may not be knowing anything about you. So he has to test you in your subject only. So whenever you think that once you complete your course, you don't think that I can throw my books. So I think after your course only, you may have to study your subject more thoroughly. So based on, you may have to prepare for interview, and interview based preparation is required for when you go for a job interview. And before going to a job interview, you have to see what type of company, what type of job you are applying. So what is the job details? You have to get the details about the type of the job in that particular organization. This will give an idea to prepare for the interview. So suppose you are looking for or you are applying for a post in a fabrication industry. So that means what is in a fabrication industry, what they will be doing. You should first have a detailed job search, and based on that, you have to prepare for the interview. So in that way, if you see you are looking for an opportunity in power plant engineering, that's what I'm saying. Based on your area, you should see what the power plant engineering basically what it deals. For that, I think I can give some idea based through this interactive session. I can able to give some idea. That is the only purpose of this talk. So I am not going to go in the details of everything, but once what I am trying to give is an overall idea what different areas we are working. So in that way, you will be able to prepare accordingly and to get a secure job. So the job opportunities in this field are very high. In the coming years, more and more opportunities going to come. So in that way, your subjects in thermal engineering, machine design, name it anything, maybe metallurgy, everything will be useful once you try to enter to this type of industry. So before going to the details, I just want to give an idea about that. So now coming to our topic, so power plant engineering. What is a power plant? Power plant basically a place where we will be producing electric power. So electric power, as you know, it is the most, it's a measure of the development of a country. A most developed country is a measure scale for measuring the development level of a country is how much electricity demand on that country. So in our case also, India is now trying to become a global power. That means we have to proportionately increase the power production to meet the energy, the demand. The economic growth is directly related to the power production. As you, the economically advancing, you need more and more power because more and more industries will be coming, more and more technological other activities will be increasing. That means you need more power. That means the growth projection of a country will be directly proportional to the growth of the power plant industry also. So in that way, India is now trying to become a global power by, as you know, by 2035 or 2050, the demand for the power is around 8 times of the present power capacity. That means you see that the number of power plants or number of power industry is going to increase in many folds. So that way the job opportunities are very high in this area. So now coming to our topic, first we see what are the various types of power plants. You know, these all are things you might have studied in your Polytechnic in your course. You might have, some people might have taught in a detailed way. So to touch upon all these things, I'll just give an oral idea of what are the different type of power plants. First one is, all we know, one is the oldest power plant, that is hydroelectric power plants, where the power is generated from the water power of water. So that is known as hydroelectric power plants. Next one is thermal power plants. Thermal power plants have different types. One is coal power plant, another one is diesel power plants, naphtha. So based on the chemical or the what is the energy source, the thermal power plants can be various types. So here in thermal power plants, basically we are generating the power from the chemical energy. Chemical energy may be coal, it may be naphtha, or it may be diesel. So there is basically a conversion of chemical power to electrical power. And the third important sector is called nuclear power plants. Nuclear power plants is in India, the energy share from nuclear power plants is comparatively very low. But in future, as I told, to meet the growing energy demand, we may have to increase the share of nuclear power plants, nuclear power production, many folds. So in that way, one of the important thing is that the thermal power plants, the carbon dioxide emission, and that we have to meet the global emission standards. In that way also, the number of nuclear power plants has to increase in the future years. And as you know, now our government of India has sanctioned around 10 nuclear power plants all over the country, and its construction is about to start. And once these things comes, the manpower requirement to operate, commission, all these things are very high. That's what I told. The opportunities for the diploma people in mechanical engineering, electrical engineering, or the BTech graduates are very high. So you should concentrate on your subject knowledge, all this area, thermal engineering, power plant engineering, and different power cycles, all these things. We have to brush up your knowledge, and as a fresher, when you apply, you should have a very good knowledge in all this. Very good means you should have your thorough subject knowledge. And the third thing is the non-conventional energy, that is called solar power plants. That also is going to be increase its share. And the last one is not the least, wind power. We have seen very many windmills in different parts of the country. So these major 5 power plants contribute to the total energy requirement of the country. So this slide basically shows the power share of our India. First part, this is the power generation by source. This is a 2017 data. You can see that around 74% of the power in India is coming from the coal. You may all know most of the power plants are coal-based power plants. So that means our 75% of energy demand or requirement in a year comes from the coal power plants. And if you see remaining, all this remaining 25% contribute from the natural gas, hydroelectric power plants around 9%. You see nuclear is only 2%, solar another 2%, oil like that 2%, and natural gas, wind, everything contribute together makes 25%, remaining 25-26%. So that means still coal power plants hold the major share in the power production in India. But if you see the world statistics, if you see in 2015, you can see that coal is only 40%. And there you see the nuclear power production is around 10%. So our nuclear share is only 2%. World nuclear power production share is around 10%. And hydroelectric power plant, you see, only 16%. Because you see that, as I told, most of the European countries and US, everything is, most of the developed countries, they have requirement of power is very high. As it's a measure of, as I told, a measure of the indicator for the economic growth. So as the country become more and more superpower, we are planning to have a superpower by 2035 or 2050. That means proportionately our power production also should increase. So for that, what way we cannot increase the coal power production too high, because as I told, it will have a carbon emission problem, greenhouse gases emission problem, and we have to meet some global standards or energy emission. The only way is to look for clean energy. That way, we have to look for clean energy, solar power, wind power, and nuclear power. These are considered to be the cleanest form of energy which doesn't pollute the environment. So you may know that in nuclear, if there is a nuclear power plant, there is no exhaust. There is, if you are having a coal power plant, there will be exhaust from the coal byproducts that will pollute the atmosphere. But in nuclear power plant, it won't be any pollution as such. Nuclear power plants have another problem. I have to accept that there is a radiation fear among the people. But in nuclear power plant, we are taking care of all the aspects of that. The nuclear radiation coming to a normal public is as minimum as less than the nuclear radiation coming from the sand beaches in Kerala. That is the measure. That means if you see in our beaches, in Kerala beaches, the radiation from the normal natural material like thorium and all much higher than a radiation level from a nuclear power plant. That way, nuclear power plant is, we'll call it as a clean energy. And only thing is you have to take enough safety precautions so that there should not be an undue accident should happen in a nuclear power plant. So once you operate in a very methodological way with more safety precautions, with expert people who has been trained to operate the nuclear power plant will become the most safest energy resources for the country. In that way, now if you see this slide in the United States, you can see that from their total energy share, 33% I think comes from natural gas. Hydroelectric power plant is only 6.5%. And 30% is coal, because the coal share is ours is 74%. If you see in the United States, the coal percentage is 30%. They have reduced drastically. And main share comes from the nuclear. Nuclear, you can see it is around 5 to 6%. Sorry, 17%, 19%. That means most of the developed countries, the nuclear contribution is much higher, so that to sustain the power demand. If you see France, the total energy demand out of 100%, 50% is coming from the nuclear production. And now, okay, people are going now try to go for more safe and more clean energy like wind and wind energy, solar energy. All these things are much safer energy, but we cannot able to meet the power demand by 2035, 2050. If we want to go as a superpower, we cannot able to meet all energy demand from only from coal power plants or only from wind. So almost all these power plants, the installed capacity has to increase by next 20 to 25 years. That means the power requirement is around 8 times of the present power production in India. That means that the projected growth, you see that last slide, if you can see the primary energy supply expected in terms of metric tons of oil equivalent, you see presently it is around this value. If you see 2017, it is only 250. What is expected is in 2042, this is the Niti Aayog chart given in Niti Aayog site. The expected power production by 2042 is around 1750. That means around 7 to 8 times of present installed capacity. You see, to meet that, we may have to install many power plants of different capacity and different source like coal. Yeah, coal also is in this slide itself. You can see that coal is we continue to provide the major portion of our energy requirement. And other thing is our nuclear power plants and other gas import, oil power plants, they contribute the other remaining part of our energy demand. So this is the last slide. This slide is the last, this in 2017, this is the figure global new investments in the renewable energy resources. Renewable energy resources by the world, by region. That means new investments are coming in the power plant production. And if you see that this slide, you can see that by 2035, India and China will be utilizing half of the total power production in the world. That means India and China is slated to become the global powers or the major economic powers by 2035 to 2050. In that way, if you are to achieve that target, that means your power production has to be, that means you are to equivalent way your power production has to increase. Then only you can meet that target. If you are lagging in that sense, you will not be able to meet the growing energy demand of the country. If you are not able to meet the energy demand, your country will not uh, flourish. Or once you want to start more and more industries, more and more technological firms, more and more other supporting industries, the power requirement will be proportionately will increase. That is the growth production. Suppose your country is growing by many folds by 2035 or 2050, corresponding increase in power production has to happen. That way, what I was telling in the expectation from our country. So that the growth production or your future in this area. So now come to the, hello, can you hear? Hello?
Yes, sir. Yes, sir. Yes, sir.
Because okay, I have to check every time. Okay. So now we'll just see some history of this power plant engineering. We all know everything, but I am putting here is known to everybody. But just have for a discussion, we can come to first we think about the history, where the power plant engineering has started. Power plant power production as a plant has started from 1750. We'll all call the our who has Benjamin Franklin's famous kite experiment. You may all know from your lower class 6 or 7 standard, famous electricity experiment or kite experiment, where he has demonstrated the electricity generated from the lightning. Lightning, we can capture the electricity and we can even use it for useful purpose. That was the experiment he was trying in the kite experiment. From there onwards, the 1750 onwards, it is considered to be the starting of the power plant industry. So that's why many of the textbook or some of the Benjamin Franklin was considered as the father of the electricity. But it is not exactly true. Many people in the similar time, people were doing experiments on various power like cells, electric dynamos. Everything has come after maybe in that era, 1700 to 800. This is the era where the electricity generation power production has started. And as you know, it started as the DC power plant. Basically started as a DC power plant. And main issue with the DC power plant was to transmit the power for a long distance. So that was the one of the limiting case for the DC power production. And this power production has been contributed by the work of Faraday, Ampere, and Coulomb. Many people have contributed for the development of the power plant industry or the electricity production as such. You know, Michael Faraday has been instrumental in finding out the DC dynamo, where basically what we are doing, mechanical energy is converted to an electrical energy. That everybody knows in our cycle and all what we are doing, cycle power is coming from the dynamo. Dynamo is basically a conversion of mechanical energy. When we pedaling the cycle, the energy of our mechanical energy is converted to electrical energy, and basically it was a DC power. So with that, it was the starting of the electric generators, and with the introduction of or the discovery of AC power or the 1800, it became easy for transmitting this electricity to the higher means longer distances. So that AC discovery made it the distribution and transmission of electric power to a more longer distance from the source. So in that way, from the electric power production industry has started as an industry from 1850 onwards. So this is some picture of what is an AC and what is DC, and electromagnetic effect of it is an electromagnetic effect. When a conductor is rotating or moving in a magnetic field, it creates electricity. Basic Faraday's law you might have studied, and from that is the basics of electricity production. That means your subject, how it is important, you maybe make a note that somebody asks what is electricity, how it is generated, you should know. We may not be giving much importance to all these things. When suppose somebody is working or planning to work in this area, he should know all these things as a fresher. So now, if you see, once the power production, AC, DC motor, DC electricity, AC diesel AC generators, all this has been developed in the 750 to 1800, as I told, 800 to 850. And the first hydroelectric power plant, as I told, hydroelectric power plant is one of the oldest power plant in our world. So hydroelectric power plant, first one of the non-hydroelectric power plant, is started in 1878 in United Kingdom or England, started by one Mr. Lord Armstrong in England. So this idea basically came from the idea of the concept of water wheels. Everybody knows what is water wheels. Water wheels is basically an instrument used to produce mechanical or a rotational power from water, power of water. This figure basically shows a water wheel in the ancient times. Water from a higher elevation, maybe from hills, they may be taking the water through the pipes, and it will fall on the water wheel. It will rotate the wheel, and the rotation is basically used for in the grinding mills at that time. And later, after discovery of dynamo, it was came to know that once we can able to rotate a conducting material in a magnetic field, we will be able to produce the electricity. That was the basic idea of electric generator. So with that discovery, power production with hydroelectric power production has started with dam and penstock and generator. Using this, we have started the power production that is called hydroelectric power stations, which is largely available in Kerala. We have mainly depending upon the hydroelectric powers, Idukki, various stations. We don't have much power from coal. We don't have coal power station. We don't have a nuclear power plant. So most of our energy demand of Kerala comes from the hydroelectric power stations. So that way, it is very important to know about hydroelectric power station. So with this charting of power plant engineering, various power plants, various type of power plants has started emerging. Various research has been started doing in this area. People are more interested to develop newer and cheaper power, method of developing newer and cheaper power. So various research and activities has happened from 1800 to up to maybe now also it is going on. And that way various type of electric power plants has been started. So as we know, it is now we come to the basic principle of power plant engineering that also everybody know. It is follows the laws of thermodynamics. We know three laws are there. First law of thermodynamics, second law of thermodynamics, third law, and zeroth law. This forms the basis for a power production, whether it is a thermal power plant, whether it is a nuclear power plant, or whether it is a wind power plant. Everything follows the laws of thermodynamics. What is the first law of thermodynamics? It basically says energy neither can be created nor can be destroyed, only can be converted from one form to other. That means here in nuclear power plants, what we are doing, we are basically converting one form of energy, whatever may be the form, into electrical energy. That is the idea of power plant. In power plant, basically in a thermal power plant, what we are doing, we are converting a chemical energy to electrical energy. In a solar power plant, what we are doing, we are basically converting a thermal energy to electrical energy. In a nuclear power plant, nuclear energy to electrical energy. And in a wind, we are basically converting a maybe mechanical energy directly to a electrical energy. So in this conversion from one form to other, we are basically going through a form of different forms of energy. In thermal power plants, what we are called energy, first it is converting to a heat energy. It is called is burning and producing heat. And this heat is further converted to steam. Steam is basically turning a turbine. That means heat energy. That means enthalpy of the steam is converted to a mechanical energy. And this mechanical energy, that means the rotation power. That means enthalpy is converted to a rotation of the turbines. Turbine will start rotating. This mechanical energy has been now finally converted to electrical energy due to electromagnetic uh, uh, method of electromagnetism. So that is the first law. So what is the importance of first law? Now everybody knows. And what second law of thermodynamics says? Second law of thermodynamics basics says about the conversion of power. We know that perpetual kind of perpetual machine of first kind, machine, second kind, all these things we might have studied. So what basically a second law of thermodynamics says, it is not possible to convert completely an energy of one form to another, completely to another without rejecting to some other thing. That means it is not easy to, or it is not impossible to convert completely a thermal energy to mechanical energy without transferring heat to a sink. From there only we might have studied about the source, sink, and the efficiency diagram, efficiency of the engines. All this has come from the second law of thermodynamics, and the idea of entropy also we have studied from second law. So second law basically defines how much energy we can produce from a source. From chemical energy, it is not possible to convert 100% of chemical energy to an electrical energy. There should be some loss, or we should have some efficiency. And efficiency is basically depends upon the cycle, how much efficient you can make. You cannot make 100% efficiency, but you can able to try to bring it to more and more close to that. If you see a nuclear power plant or a thermal power plant, the efficiency is around 40%. That means only that 60% is we are losing. So it is not able to, an old power plants, efficiency was in the order of 20 to 30%. And newer technology, newer and new research in this area will be able to make more and more efficient power plants. That means we will be able to more efficiently convert from our source of energy to electrical energy. So this basically, second law basically teaches the how much energy can be converted, and what is the most efficient cycle is, we have studied it, is the Carnot cycle. So the efficiency achieved from a Carnot cycle is the ideal efficiency, and all other cycles efficiency is lower than the Carnot cycle. So in that way we have studied different cycles and different cycles, efficiency of different cycles, and this knowledge basically helps to develop newer and newer conversion engines or power plants, and different type, based on that different power plants has been emerged. And the third law basically defines the zero, absolute zero. It is not possible to achieve an absolute zero of zero absolute or zero Kelvin. It is very difficult to achieve, and it's a measure of entropy, zero entropy. And zeroth law, what is the application of zeroth law? Zeroth law basically helps in developing the measurement. So all we know, the measurement has come from the zeroth law. That means two bodies are in thermal equilibrium with the third body, and these two bodies are automatically in thermal equilibrium. I am not telling the exact definition. You may be knowing from your textbook. That is the thermal equilibrium of the bodies helps in developing the measurement techniques for temperature. So basis of temperature measurement is the zeroth law. So that this shows that the importance of studying the thermodynamics, thermal engineering for giving more expert knowledge in the power plant industry, or any type of nuclear, thermal, or any type of power plant industry. You should know about the basis of thermodynamics. You should know the thermal engineering. All this should be thorough, and you should have a good understanding what is the application of these laws in this industry. And coming to again to our hydroelectric power plants, as I told, it was one of the oldest kind of power plants. And now also in the world, around 17% of the world power is coming from the hydroelectric power plants. And if you see the hydroelectric power plants, there are three types of hydroelectric power plants. One is in impoundment, diversion, and pump storage. That means impoundment means this is nothing but the power is coming from a dam. You will construct a dam, keep your water column at a very high level, and construct a power plant at the lower level of the dam. And using here, what we are using here, basically converting the potential energy stored in the dams, water. We are converting potential energy into finally to an electrical energy. So this is a basic conversion of potential energy to electrical energy. And another type of power, hydroelectric power, that is diversion type. Here what we'll have some rivers at the higher elevation. We'll simply divert the water flow from that river. We won't construct a separate dam and all. We simply divert the flow to a generator. It is situated at the downhill. So from hills, water source, it will divert and we will get the power based on the elevation difference. And the water power is here also, water kinetic energy of the water is converted to electrical energy. And in pump storage hydroelectric power plant, how it basically works is our power demand varies from at various times. And power requirement at the daytime will be much higher than the power requirement at the night time, because daytime all offices are working, all industries are working, all people are busy with their now online classes. That means the power requirement during daytime is very high, and power requirement in night time is very low. So what we'll do, we have a dam and we have a lot of water. What we'll do, we will try to use this power. Even though the power demand has come down in night time, we try to divert this power to pump the water to a higher elevation. That means you just store the water. When at that time you have a lot of, suppose you are getting a lot of rain in Kerala. At that time you start operating all the power plants every time. So whenever demand comes down, also don't stop the power plant. Power plant cannot be stopped. At that time, even though the grid requirement is very low, what we will do, we'll pump back the water to a higher elevation using this power. That means you store it. And when the demand comes, again you take it from that. That way we can use, that is not required in our Kerala and all, but there is a shortage of power somewhere, we can keep it, and whenever demand comes, you can start pumping back. That is basically you are storing the energy in the form of potential energy. That is called pump storage. So this type of power plants are not generally used, but these are the different type of hydroelectric power plants. And as I told, so mechanical engineers are basically in this hydroelectric power plants. They will be involved in the calculation of the flow rates, what should be the size of the pipe, what should be the size of the turbine we have to use, and how much, what are the sensors or what are the flow measuring instruments we have to use, and what are the different charts. They should know about the usage of different charts and calculate various calculations they may have to do. So mechanical engineers is playing a major role in hydroelectric power plants. So even a new hydroelectric, so mainly it is contributed by mechanical engineers and electrical engineers in this hydroelectric power plant. Now come to these are some of the figures as what I explained. This is a dam, it is an inbound type power plant. From the dam it is going to the power station using the large pipe known as penstock. That means here the potential energy of stored energy is converted to kinetic energy, and finally kinetic energy is converted to mechanical energy or the rotation of the turbines, and the turbines, it is from the turbine it is generating the electricity. This is the turbine generator, cross section of a turbine generator. You might have studied about different turbines, Kaplan turbine, Francis turbine, all these things. And this basic, these turbines are used for converting electricity from water. And these are a picture of one of the power plants in the European countries. And next comes the second type of power plant, that is known as coal-based or the thermal power plants. In that thermal power plants, major contributors are, as we see in the initial slide, coal is the major contributor in the thermal power plant. There are other power plants, diesel power plants. We have Kayankulam, we have diesel power plants, and naphtha power plant. But major contribution energy source is from coal. What is happening in the coal power plant? The coal will be made it to pulverized and it is sent to a boiler. And in the boiler, this coal will be burned and the energy, coal energy, chemical energy of coal is converted to thermal energy. This thermal energy is used for heating water. Water will become water in the taking this heat, water will become steam. That means water will boil and become steam. That is the you might have studied in your thermal engineering how the conversion of water to steam, the cycles, TS diagram, PV diagram is a TS diagram of a water means steam cycle, or the Rankine cycle has been shown in this. So most of the power plants, thermal power plants, are working based on the Rankine cycle. And Rankine cycle, it is a steam cycles where the electricity is generated from the power of steam, or the thermal energy is converted to electrical energy. This is the cycle diagram of the thermal power plants. As I told, first heat is generated in the boiler and water will be fed through the tubes in the boiler, and heat will be absorbed by the water while passing through the boiler. It is nothing but a heat exchanger. So you should now know what is a heat exchanger, different type of heat exchangers, how it is working, how the efficiency of heat exchanger is calculated, what is the enthalpy, what is the efficiency. All these terms will come in this case. So in the boiler, it is nothing but a heat exchanger. Heat will be exchanged from the furnace to the water, and water will take this heat and become steam. And the steam, high pressure steam, high enthalpy steam will be first passed through a first stage, that is called a high pressure turbine, HP turbine. And this turbine, you know the working of a turbine. Turbine blades, it will be injected to the turbine blades, and based on the rotation, it will start rotating, and it will our conductor will be rotating in a magnetic field, and from that it is nothing but a generator. Generator will generate the power, and it will be connected to the grid. And high pressure turbine, not only these are like something like a multi-stage turbines, multi-stage turbine generator. That is, first stage will be a high pressure turbine. There some cases there you have an intermediate turbine, and finally you have a low pressure turbine. That means here what we are using, we are trying to increase the efficiency of the operation. You might have studied how to increase the efficiency by a reheat cycle. So here we are basically using a reheat cycle for this power production. So importance of reheat cycle is we will be able to improve the efficiency of overall efficiency of the system by using a multi-stage turbine. But first high pressure turbine, second medium middle turbine, intermediate turbine, then low pressure turbine. In between, we will improve the quality of the steam. So the term quality of steam also is should be very important. What is a percentage steam and what is a percentage of water? That basically determines the quality of the steam. So improve the quality of the steam. This will be again passed through a economizer. Again, it will be reheated and sent through a low pressure turbine. Once it is passed through the low pressure turbine, finally it has to come to a component called condenser. This is the first law of thermodynamics, second law of thermodynamics. This is the source, this is the condenser is the sink. Source is at higher temperature T1, condenser is should be at very low temperature. That means we should be able to reject the heat to a sink. Boiler is the source and condenser is the sink. So we will be rejecting, or it is our this is our T1, this is our T2, and based on the T1, T2, and this based on the cycle diagram, we will be able to calculate the efficiency of the power production. And as I told, we use multi-stage generator. We can able to use a reheat cycle, and we can able to improve the efficiency. And this condenser, how we will condense? Either generally we will use this also a simple heat exchanger. Heat will be, steam will be coming in the shell side, and water will be going through the tube side, and heat will be transmitted or transferred from the cell side to the water in the tube side, and water will get heated up, and this heat further it will be cooled using a cooling tower. The whatever even you see in the if you see in I don't know in Kerala it is there. If you go to the Telangana or Andhra Pradesh, you can see so many power plants. If you see in the travel in a train, we can see many power plants constructed by NTPC. I think Kayankulam also you may be able to see this. So these are big structures are known as the cooling tower. Cooling tower is that also you might have studied in your course. What is the function of a cooling tower? It basically cools the water coming out of the condenser. This is a recirculation type. Some cases, if you have abundant water, you don't need a cooling tower. Suppose you are constructing a power plant near sea, so there won't be any cooling tower. What will happen? The water which is getting heated up directly will be rejected to the sea, and fresh water will be taken from the intake. Water intake structure in a which will be constructed. You might have seen a long intake in the sea. So fresh water will be taken from the sea, and this will be sent through the condenser, and hot water will be again returned back to the sea. So here we don't need any cooling tower. Cooling tower is required only in case we are circulating this water. There is a scarcity of water. We cannot have the luxury of taking water, fresh water, and again throwing it back to the sea or some river. Suppose if you have a very good river or a big river nearby, then also you don't need any cooling tower. So if you have a scarcity of water, you may have to install a cooling tower. And the working of cooling tower also, it's important how it is working, the knowledge on the working of the cooling tower cycles. Now you might have understood what is the importance of all these thermal cycles, how it is important. And finally what it happens, it is the water or the steam which is now it is in the form of water, again pumped back to the boiler using a feed water pump. This is the stage. You can see the 1-2 stage shown in the TS diagram. It is a pumping stage. Again it is heating in the boiler stage and become superheated steam. It is a superheated, you can see the 4 to 5. 0.5 is a superheating. Water becomes superheated. Again in the turbine, the whole heat or the energy is converted to electricity and become again water while passing through the condenser. This is the working of coal-based thermal power plants. Here, as I told, the energy is converted from the chemical energy of coal to electrical energy. This is the energy conversion. And how the conversion is happening, we have now seen. And this is a detailed picture of a coal base. As I told, what are the function of the cooling tower? This picture shows the two types of cooling tower. One is induced or natural or induced natural draft cooling tower. Another one is forced draft cooling tower. Two types of cooling towers are there. In induced or natural draft, what will happen is water will be sprayed from top. It's hot water coming from the condenser. Left hand side, the picture is a condenser. As I told, in the condenser, steam will be passing in the shell side, water will be passing through the tube side, fresh water will coming from the cooling tower will pass through the tube side and get heated up. Again it will be hot water will be come to the cooling tower back, and it will be sprayed from the top. You can see so many nozzles at the top. From through these nozzles, water will be sprayed, and that means you are basically increasing the area of contact. That also you might have studied in your thermal engineering. Heat transfer will be better as you increase the area of contact. So that is the purpose of spraying the water. So once the water is coming through a pipe, you cannot simply throw it through that. So if you spray it, that means water will become like a droplets, and surface area will increase. That increase in surface area will help in more heat transfer. So water will be sprayed from the top, and fresh air will be circulated through this. There will be some mesh through the mesh. Air will be circulated up, and the air, whatever heat will be transferred from the hot water to the air. So once air get heated up, as we know, as the density will reduce and denser air will go up, and cooler air, high density, low density air will go up, high density air will go down. So using this, there will be a natural circulation will be set up in this. There is no external fan or is installed in this, only by the change in density. Now you understand the importance of density variation in the gas. You might have studied a little bit on the gas dynamics, I think, in your course. So that is the application of the gas dynamics. As the density reduces, it become up. It will go up, denser air will come down. So this will create a natural circulation. And the shape of this cooling tower also basically help to having this natural draft. You might have studied about the convergent divergent nozzle. This is something like a convergent with a divergent portion is not there. It's almost more like a section will only convergent section. It will, as the it is converging, what will happen? It velocity will increase, pressure will reduce. So due to that difference in pressure, free flow of air will take place. And that means you need a very large size of the cooling tower. You see, this is a natural type of natural draft cooling tower. You need very high, that means it's around 122 meters. But if you are not able to do it, maybe means constructing of this type of natural draft will be very difficult, or it will be more complicated. In that case, you can afford it. You can go with a space problem, all this thing is there. You can go with a forced draft cooling tower. In forced draft cooling tower, the principle is same. The principle is same. In order to not to depending upon the natural flow, what we are doing is we are creating a draft here using a fan, very big fan. That means power requirement in this case will be, there's an external power requirement. Part of the power produced in the nuclear power in the power plant will be transferred to the rotation of these fans. The rotation of fans required maybe in terms of megawatt. So you need to rotate, or you need to supply some energy which will rotate the fan. It is nothing but a exhaust fan. Exhaust fan, how it will work? It will take the air from inside, it will push the air out. So the working of this fan will help you for the circulation of air through this cooling tower. That is called forced draft cooling tower. So any of this generally based on the availability, based on the requirement, we will be going for either for a induced draft or a natural. Most of the power plant generally will go for a natural draft cooling tower, because that's what we are seeing, very high drafts. And some other cases, the space availability and all is there, you can go with the forced draft cooling tower. So this is the two different type of cooling tower, and we have seen what is the function of the condenser in a nuclear power plant, and what is the function of boiler. Almost all the things has been explained in this. And here, this is the chimney, as I told now. Chimney in the boiler, all will be burned, and the ash, fly ash, all these things will be passed through the chimney. Here also, it won't be transmitted directly to the atmosphere, because it will be emission norms. So it will be against the emission norms. That's why some power plants, court is telling to close it down and all, because some power plants, they will not follow the emissions norms. Actually, they have to keep so many filters in this chimney. Long chimney you have seen. You see, these are the chimney in the power plant where the fly ash will be going out through this. So there are some filters will be kept along this height, and it will absorb the carbon particles or the emission, to reduce the emission. So as far as possible, we should try to minimize the carbon emissions or this emission to our atmosphere. So this is the main problem with the coal-based thermal power plants. So emission will be very high. And still, even though we are using various filters of different kinds, this is also another research area of the behavior of the filters, different type of filters, how it will work, how it is effectiveness of the filters. All these things are different research area. People are working in this area, and people are working to develop cooling towers. There are some companies working to on the design and development of cooling towers. There are also, as you know from this, these all are mechanical engineering application. You should know that fluid mechanics. You should have a thorough knowledge about the thermal engineering. You should have strength of material knowledge. You should have the metallurgy knowledge. All this knowledge together required to working in this field. Whether you are working in the design of the cooling tower, you may be working in the installation of cooling tower, all these things, or you may be working in the area of condenser design, condenser fabrication, condenser testing. All these things are various people having diploma in mechanical engineering is required in this area. Now, another important as which we are working now is the nuclear power plants. Excuse me, you can hear? Hello? Hello?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. So when I continue, I may not be knowing whether it is got cut or not. So that's
It's
why I'm
going good.
checking in this. Yeah. So now we come to the case of a nuclear power plant. Nuclear power plant, as I told, is about 10% of world's electricity is produced from nuclear energy. But in India, it is only 2%. You know, there are so many oppositions, all these things in India. But in developed countries, that much opposition is not there. People are more knowledgeable in that sense, means general sense. Knowledge in the sense there another advantage is that is not highly populated. India is highly populated, and it is generally nuclear power plants and all generally started at some remote areas where the population is very less. So India, especially in Kerala and all, if you see the population is very high. It is like almost where it is like a town. It's like a city like Bombay. Kerala, if you see, every place is like a city like Bombay. So we don't have any place to start a nuclear power plant or a thermal power plant. That way, that's why we another issue with Kerala. So we are depending to other states for our electricity. So one of the important thing is the development of nuclear power plant is now the research is in the area of developing very small nuclear, that is called modular nuclear reactors, very small size. The idea is we should be able to start a nuclear power plant even in a city, middle of the city. That is the idea, the way the research is going in this field. So that is called modular nuclear reactors. So as far as now it is, we discussed the nuclear power plants. Cost component of nuclear power plants are very high because it installed the installation cost for installation and maintaining a nuclear power plant is very high. In the terms of we are spending lot of money and systems have been installed in a nuclear power plant basically to take care of safety of the nuclear power plant. Importance of a nuclear power plant is first is safety. You won't take any chance regarding the safety of the nuclear power plants. You can see that any of the nuclear, we have one level, 2 level, or 3 level safety criteria. And this safety criteria has been well laid by the various safety agencies. So when you start a nuclear power plant, we have to follow some safety guidelines, and we have to ensure that these guidelines are strictly followed. So the design, construction, installation, commissioning, and operation of nuclear power plants are based on some international standards like American Society for Mechanical Engineers and the American Society for Civil Engineers. There are some safety guidelines or the design codes are provided by these institutions, and it is all are stringent. That means to design a power plant, design power plant component, we have to follow stringent safety criteria. The factor of safety of each component. You might have studied about the factor of safety. That means actual allowable. Here comes the knowledge of the strength of materials. You should know what is yield stress, what is Young's modulus, what is ultimate stress of a component. So a component design should be in such a way that it never crosses its yield stress. And that means you have to apply a factor of safety on the yield stress. And at any time, even at the unexpected conditions, the stresses in the component should not exceed the yield value. That means the component is not going to fail at any time. That way we have to design the component for that is the case with even the coal power plants. When you design a boiler design in such a way that when even under some accident condition, what will happen, the boiler pressure may increase drastically, and if you are not taken that safety, then boiler may explode. So there are some, you can see that many cases, even the coal power plants, that guidelines what they are following is not as much stringent as a nuclear power plant. Nuclear power plant, because of the radiation problem, we have to take care of, we will not compromise on safety, and the cost involved for ensuring the safety is little higher. That's why the nuclear electricity is not that much cheap as hydroelectric power. And once it is installed and started operating for a long time, that means long time you'll be able to make it able to generate electricity at a cheaper rate. If you see the boiling water reactors in the Tarapur, where it is the oldest General Electric power plant, it now generate electricity at the rate of 2 rupees or 1 rupee per unit. So, but it installed time, nuclear electricity will not be cheap. It may be more than 5 to 6 rupees. But as you operate the power plant for a long time, because further there is no requirement, because you can see that that's like very important thing is heat produced from 1 kilogram of uranium, that is the fuel of a nuclear power plant. Basically, it produces around equivalent to around 2,500 to 3,000 tons of coal. That means if you have 1 kg of uranium, it will produce an electricity equivalent to 3,000 tons of coal. So that is the advantage of that. Means large energy is produced by the nuclear chain reaction in a nuclear reactor. So that is the advantage. And the emission, there is no carbon emission, there is no any greenhouse gas emission, nothing is there in a nuclear power plant. Only problem is the radiation. That means alpha, beta, gamma, like different type of radiation will be coming from the nuclear reaction. And we should know, we know that we have know how the know how or the we have the technology how to contain this radiation. Some of the radiation even can be stopped with a paper. That means beta radiation even can be stopped, alpha radiation can be stopped with a paper, beta radiation even can be stopped with water, even gamma radiation can be stopped with concrete. So if you put very thick concrete and very thick water column, we can are able to attenuate or reduce the radiation coming out of a nuclear power plant to a bare minimum. That means you can even go and stand nearby a nuclear power plant, and the type of radiation you may be getting is much less than, that's what I told in introduction, I don't know if people heard that, much less than the radiation when you we are getting when you stand in a beach sands. We have the nuclear radioactive material like thorium, small part of uranium, all these things, and the radiation coming from a beach sand is much higher than the radiation coming out of a nuclear power plant. That way we have to design the nuclear plant and then demonstrate also. We have different demonstrations and we have to get the safety clearance from the safety authorities. Then only we can operate a nuclear reactor. So this nuclear reactor is considered as one of the cleanest energy in the world. That's why many of the developed countries are going, major share of energy comes from the nuclear power plant. That's what I was telling France. France, 50% of their energy demand is fulfilled by the nuclear power plant. And worldwide, we can see this as source of most of the 63% source of emission-free electricity comes from nuclear power plants. Out of this 100%, nuclear power plants contribute 63%. That means sources of emission-free electricity. And hydroelectric power plants, yes, there is no emission, but it has natural impact when you start a hydroelectric power plant, constructing dam, other natural problems, our environment problem. It will it may basically large area of the forest may be coming underwater and ecological problems will be there. That's what some we are hearing about, some opposition against Adirapalli power project, all these things. Once you construct a dam to produce a thermal means hydroelectric power, our ecology will be affected. So, but in a nuclear power plant, that type of issues are not there. But only issue is the radiation, and you have to have systems to take care of in case of any issue comes. Even there should not be, public should not be get affected. That way you can see that even Fukushima, that is now the one of the thing which is going against nuclear power, Fukushima accident. In the Fukushima accident also you can see that even though there is a large earthquake comes, even the power plant, nothing has happened. That means all the earthquake systems and components are designed to withstand a earthquake, very major earthquake. That means when you design a nuclear power plant, you have to consider about the major earthquakes and even a higher than the what is expected in that area. That means even a very, very big earthquake comes also, the nuclear power plants should withstand that vibration. That way we have to design a nuclear power plant. And what happened in Fukushima is not due to earthquake. What happened is after an earthquake, a tsunami has come. It has destroyed the cooling circuit of the nuclear power plant. What is happening in a nuclear power plant is even in Fukushima, once an earthquake has come, the nuclear power plant could able to shut down very safely. That means our sensors have worked perfectly. A reactor able to shut down all the 4 reactors, shut down very safely and kept the reactor in a safe shutdown condition. What happened is after 2 hours, tsunami struck the site and it has destroyed the cooling circuit of the nuclear power plant. Issue with the nuclear power plant is once you shut down the nuclear power plant, there will be small nuclear reaction will be continuing in the reactor core, and that core has to be cooled for a long time. So the people, designers or the planners in the Fukushima never expected a earthquake and tsunami coming together at a particular location. Yes, it has been considered, but the level of the tsunami height that has considered in the design was much lower than what has happened in the Fukushima. So in that way, the cooling circuit has been failed, and because of that, reactor cooling system has temperature has increased, and because of that, some hydrogen, the explosion what happened in that plant was not due to nuclear reaction. It was due to a hydrogen explosion. That means the nuclear power by one byproduct is hydrogen. Hydrogen will be very explosive. So hydrogen will combine with vapor in the atmosphere and it will become an explosive. In that way, it has exploded. That was some accident has happened in Fukushima, but there was no public damage. Nobody has affected with that. So that much safety level we are designing the nuclear power plants. So the fear against nuclear reactors should be people should feel that it's one of the safest and clean energy. You think that it is like an aeroplane. If you go in an aeroplane and aircraft crashes, many people will die. But even that much people cannot die in a nuclear accident. There are systems, one, two, three, or four type of systems. Duplicate, triplicate systems are available. One fail, another should take care. Another fail, the third system should take care. Like that, 3 levels of safety is considered in this type of power plants. So that is, so as I told, it is the 10% of world electricity is produced from the nuclear power plants. And there are different type of power plants. So whether I am exceeding my time? Hello?
No problem, sir. No problem, sir.
Yeah. So I try to, yeah.
എത്ര സമയം വേണ്ടി വരും സജീഷ്?
ഹലോ
എത്ര സമയം വേണ്ടി വരും?
ഹലോ
സജീഷ്
എന്തോ
എത്ര സമയം വേണ്ടി വരും ഇനി തീർന്നെങ്കിൽ?
15-20 minutes.
Okay.
Or I will rush through, no problem.
Okay.
So there are different types of power plants are available: boiling water reactor, pressurized water reactor, pressurized heavy water reactor, fast breeder reactor, high temperature. These are the different type of nuclear power plants available, and it basically works on the principle of nuclear fission. Everybody knows how nuclear fission has happened. That means very large nuclear like uranium and plutonium is highly fissionable. That means a high energy neutron hits on this type of materials, it will undergo fission. That means it will break into 2 different atoms, and the remaining mass will be converted to large energy. This is called missing mass, or the energy, large amount of energy is generated by the breaking of these atoms, and this energy is taken. This energy is in the form of heat, and this heat is used for boiling the water or converting the energy into a useful form of energy. Here, uranium, you can see this is a chain reaction. Basically, one neutron hitting one uranium atom, and from breaking of uranium atom, it will generate many neutrons, and these neutrons will hit the nearby atoms, and it's called like a chain way it will go. So we here in a nuclear reactor, we are controlling these chain reactions and keeping it in the critical conditions, so that controlled nuclear reaction is used in a nuclear power plant. If it goes uncontrolled way, it will become like a nuclear bomb. So nuclear bomb is nothing but a uncontrolled chain reaction. So in a nuclear bomb, but there is a minimum mass is required for the spontaneous nuclear reactions, spontaneous explosion. That is called critical mass. So in nuclear reactors cannot become like a nuclear bomb, as many people are saying, because the critical mass kept in a nuclear reactors much lower than a critical mass in a nuclear bomb. So you need a minimum amount of mass, but the nuclear reactors are below critical, working on a below critical region. So what will happen is uncontrolled chain reaction happens, large amount of heat will be generated. Even the fuel may melt, and that melting will have some other effects. So you should take care of the high temperature generated in the nuclear fission reaction. So it never becomes a nuclear bomb like what people are sometimes misleading the people. So that I want to tell in this. So in boiling water reactor, what is happening is water is passed through the reactor. In the reactor, the core will be uranium-235 and enriched uranium, and controlled nuclear reaction will be taking place in the reactor, and the heat will be transferred to the water, and water will boil and become steam directly. Only thing, this is directly coming from the reactor, and this boiled water is sent to the turbine, and heat will be converted to electrical energy in the generator, and that is the only difference. So here in the nuclear reactor, only difference is the source where the energy is generated. In all power plants, coal is the source. Hydroelectric power plant, water power is the source. Here the nuclear energy is used to heat the water. All other part is called the balance of plant, we will call it as. It is the same as all other nuclear power plants. So here water is boiling, and the pressure of the water will be around 117 bar, and the temperature of water. Why we are pressurizing the water? If you pressurize the water only, water boiling point will increase. Water under normal pressure, atmospheric pressure, its boiling point is 100 degree. So we may have to pressurize the water to increase its boiling point. That is the basic idea in pressure cooker also. We know pressure cooker, what is happening is we are basically pressurizing the water to increase its boiling point. So here also in a reactor, what we are doing is we are pressurizing the water to get a higher boiling point. Here the boiling point will be around 285 to 300 degree. Water will boil, and the boiled water, high enthalpy water will be, steam will be passed through the turbine, steam turbines. In pressurized heavy water reactor, it is similar to boiling water reactor. Only difference is water will be pressurized in such a way that it will not boil. Water passing through the reactor will not get boiled. So this first, you have one loop. Here the loop with water passing through the first loop, passing through the reactor will not get boiled, because the pressure here is in the order of 170 bar. 170 bar means very high pressure, and water will not, water boiling will be much higher than 400 or 500 degree at that time. So 170 bar, that means under normal temperature, water will heated up to 350 degree, and it will transfer this heat to an intermediate circuit. Here that is called heat exchanger or steam generator. The water coming from the turbine will pass through the steam generator, and the primary circuit in the reactor will transfer the heat to the water in this steam generator, and steam will be produced in this second circuit. This is called steam generator, and this steam will be passed through the turbine. That means directly whatever is passing through the reactor core is not coming with the turbine. But in other case, the water passing through the reactor core, let's say maybe radioactive water, will be passing through the turbine here. But here the radioactive water is not passing through the turbine. Radioactive water basically transfer the heat to a secondary circuit, and this secondary circuit water will become a boil, and the enthalpy in high steam will be transferred to generate electricity. Here is a picture of the cross section of a nuclear PWR, and this PWR basically started, it's a very compact reactor. This reactor has been discovered in USA by our laboratory along with General Electric. This reactor was basically devised or designed to put it in the nuclear submarines. Very small reactor, very compact. Nuclear submarines are run based using pressurized heavy water reactor. Our nuclear submarine also now it is running with a pressurized heavy water reactor. Next is pressurized heavy water reactors. These are the not most common, but is very common in India. In India, most of the reactors are called pressurized heavy water reactor. It is different from PWR, pressurized water reactor. What is the difference is, in heavy water is used here as the moderator and coolant. Here in the boiling water reactor and pressurized water reactor, normal water is used as the coolant and moderator. Moderator is nothing but moderating the neutrons. So I am not going to the details about that figure. That means basically we have to slow down the neutrons, have a better efficiency to improve the efficiency of fast neutron. The neutrons coming out of from a chain reaction will be having high energy. That has to be slowed down to hit the next neutron, next fuel element. Otherwise, these neutrons will be escaped. So to make the neutron efficiency more, we have to slow down the neutron. That is called moderation. So in pressurized water reactor and the boiling water reactor, we are using normal water as the coolant and moderator. But in pressurized heavy water reactor, heavy water is used as the coolant and moderator. Heavy water is nothing but deuterium oxide. That means deuterium is the isotope of water. So H2, it will have a this one, hydrogen have 3 isotopes, hydrogen, deuterium and tritium. So deuterium oxide is used for creating the water. That is what water is called heavy water. So its atomic weight is higher. So heavy water is much heavier than a normal water. So heavy water is used here, and this is a circuit for showing the pressurized water reactor. And this third type is the fast breeder reactor, where we will not moderate the neutrons. Fast neutrons is used for generating electricity or creating the nuclear fission reaction. The reactor what we are working here in Kalpakkam is basically on fast reactor. Here the coolant used is not water. We are using sodium as the coolant. Primary coolant will be sodium, and this sodium coolant will be transferring heat to a secondary loop, again like a steam generator. It will take the heat. Water will take the steam heat from the sodium, become steam, and it will again go to the turbines. And as is like a balance of plant, it will be same as all other power plants. Only the power plant differences comes in the source of heat. Here nuclear reaction transfer the heat to primary sodium. Here primary sodium will transfer the heat to the secondary sodium loop, and secondary sodium loop will be finally transferring the heat through a heat exchanger to generate the steam, and that steam will be transferred to the turbine to generate the electricity. And this is the how the reactor core will look like. So many, and it will create even to generate not only generate electricity, it is creating more fuel also by breeding. That's what the word breeder is coming. So I am not going to the details because of lack of time. Another third reactor is gas cooled reactor. This is an emerging type of reactor where the gas is used as the coolant. In this case, earlier it was water and sodium. Here gas will be used. Graphite will be the moderator, and it can go even very high temperature. This is basically in the order of temperature. As I told, in the pressurized water reactor and boiling water reactor, temperature of the water is in the order of 300 degrees. In fast breeder reactor, temperature of the water sodium is in the order of 500 degrees centigrade. In high temperature gas cooled reactor, so temperature is in the order of 1000 degrees. So here the more complexity. As the temperature increases, the design of the components, everything become more and more complex that we can see. So that is one challenge to design this type of reactors. And these are the basic power conversion cycles in use in the various. This already we have explained. It may be, if it's a gas turbine, we will be using Brayton cycle. If it is a normal steam turbine, it will be, we are using Rankine cycle. So Rankine cycle, Brayton cycle. The importance of these two cycles comes in handy in the understanding of this cycle will become important in the power plant operation. And now come to the important point, the role of these engineers or the mechanical engineers, diploma holders or VTech degree holders. They have a very important role to play in this power plants. I explained many things in the introduction. So in that way, as I told now, it has encompassing so many roles. First is from design of the nuclear power plant. Next is construction or fabrication of the components. Once components are fabricated, it has to be put in some place, and you have to construct the nuclear power or nuclear. So it is common for any type of power plant. All these steps are common for any type of power plant, whether it is nuclear power plant or thermal power plant or a coal power plant, anything. So these steps, the requirement is the same. So we need people who will be able to design the various components of the power plant. That design also includes two types. One is conceptual design, one is detailed design. And once the design is over, this design drawings will be given to the people who is fabricating various components. Various industries, ancillary industries are there who will be responsible for fabricating the components required for the power plant, like boiler, pressure vessels, piping, condenser, cooling tower, turbines, various systems like. Hello.
No problem, sir.
Hello?
It was a participant. No problem.
Okay, no problem. Okay. I thought somebody was trying to tell something. Okay. So fabrication. Now, next, once they have to do fabrication. Fabrication aspects, you should have the knowledge about the heat exchanger. You should have the knowledge about the power plant components, heat transfer, and you should know the various welding techniques. You should know about all these things. So here also various stages, procurement of the components. There are also mechanical engineer, all these people has to work. We have to prepare a specification for procuring the items. Then fabrication of the fabrication shop. Then quality assurance. That means non-destructive testing. Then site engineers. That's once you fabricate the component, it has to go to the site, and we have to erect these components following some certain guidelines. You cannot simply erect. You have to follow. You have to see the drawings available at the construction drawings, and you should understand the drawings. And the site engineer should be in a position to give direction to the workers in the site for the proper installation of the item, taking care of the safety. Safety is very important. So when some safety hazard happens, the whole program will stop. The whole project may stop for many years. So in that court case will be there. Further, it will go in a unending process, and it will be ending up as a non-profitable attempt. So this way we have to take care of the safety is very important. So site engineers has to be trained for that. Then finally, after erection, the system integration. Then finally testing. Then comes the third part, operation. In operation also, we have to have a control room specialists in engineers who are having knowledge about the mechanical aspects, the power plant, the components, power plant operations, everything. They will be get trained in the industry, and they will be put up as the shift engineer. And in a control room itself, 4 or 5 people will be in charge, and they will be operating. You know, the power plant is working in the round the clock. So it will be in a shift. People have to take care of the control room. They are the basically the brain. And plant engineers, these people will see overall the plant responsibilities in the overall plant. And he will be basically listening with or interacting with the control room engineer and the boiler or operating people or the maintenance people. So these are the functions in the operation. And as I told in the conceptual design, first is planning. We have to have a planning what type of power plant we are going to construct, whether it is a nuclear power plant or thermal power plant. That design, what type of concept, what type of size, what is the capacity of the power plant, how much size it will be there, what should be the position of different equipments, layout. You have to have a good knowledge about the drafting, AutoCAD, computer-aided design, and walkthrough. Means now it is all our 3D walkthrough. You should be able to visualize the things, and people knowing the 3D simulation software are well in demand. So you should have a better knowledge about the AutoCAD and the design drawings, understanding the drawings. Everything is very important in the even the planning and layout finalization stage. And at piping layout, we may have to finalize. Equipment layout, we may have to finalize. Its preliminary design has to be finalized. Once you have the conceptual design, then only the detailed design will take care. That means you have now arrived at the size of the nuclear power plant, almost all the type of the components, location of the components, everything has been arrived. Now you have to do the detailed design of each component, pressure vessel, piping, condenser, cooling tower, all this component has to be designed. That means knowledge about the full knowledge about the heat transfer, thermal engineering, mechanical, metallurgy, knowledge about the strength of materials are very important in the pressure vessel design, boiler design, heat exchangers, and piping system. All these cases also, all these knowledge skills are very important. And many people will be get absorbed in the diploma level. It's a freshers. Last year in our organization, around 80 people has been recruited through, because we have a lot of power plant projects, and in that case around 80 people have been recruited in last time in diploma, mechanical diploma alone. I don't know if people are aware of about this. So people should look for some advertisement coming in the newspaper. This year also I am taking this opportunity to tell that this year also around similar number, 80 to 100 numbers advertisement is going to come. So people are coming out of now, freshers coming completing the their diploma can apply for this. So your skill set, you have to try to improve your skill set. And as I told, if you are putting in the design and the helping in the design, you should have a basic knowledge about the strength of materials, fluid mechanics, pressure vessel design, and thermodynamics, first law, second law, third law, what is how it is work, all these things, heat transfer, knowledge about the sensors, measurement system, different type of flow measurements, temperature measurements, and pressure measurements, all these type of systems. And in advanced level, knowledge about finite element analysis, that and all not very must, it's a added advantage. So finite element metallurgy, all these things are or maybe can be a preferred skills for this. So basic knowledge should be there, and additional knowledge will be a preferred in that area. That is in the case of detailed design. Now comes to these are some of the figures I just put for understanding the design of a nuclear systems. This is a pressure vessel, this is the piping system, and these are some simulations. Even our reactor has to be designed for aircraft impact. We may have to do a aircraft impact simulations. All these things, high-end simulation, we may have to do. And then the knowledge about material, metallurgy, materials, chunks of materials, everything will come in this. So that subject knowledge is very important. Then comes the fabrication, as I told, first is procurement. So procurement, we have to make a detailed specification. There also you should know about the systems, then only you can make a detailed specification. So knowledge about this and understanding the specification and send that for indent. Once it is placed, that indent, then comes to the fabrication. And that means you are now the fabrication floor. Suppose you are getting an order from a big power plant industry to construct some component, and you are now put up as the person who is overseeing this job. So you should understand, you should be able to read the drawing. You should understand how the drawing basically tells what. So the understanding of drawing and translating to a product is very important. Who can able to understand the drawing and drawing conventions, maybe projections, right angle, front view, isometric view, all these things you should know. Then only you will be able to communicate with the worker who is doing this fabrication operation. So you will be put it as a supervisor for this job. You should have knowledge on all these aspects. Then you should fabricate this item, and then various operation like welding, forming operation, welding operation, forging, everything will come in this. So that activities has to be done. So then finally comes the inspection of the components. Component has to be inspected. Then quality assurance. We'll do some non-destructive testing like liquid penetrant testing, ultrasonic testing, radiography testing. Some people will be working in the quality assurance, and there also all these new techniques will be used for testing the components. And component testing also very important. It will be tested at the high pressure. Suppose it's a pressure vessel, the testing will be done at 1.25 the design pressure. That way testing will be carried out. And these are some of the photos of some fabrication jobs which were for our reactor. You can see the size of the component. The people are standing here. This is a pump section, and these are the core support structure where the nuclear core will be mounted. These are the pipe cross section, all these things. These are some of the fabrication activities. You can see the fuel elements in a nuclear power plant. There are pipes and the turbine checking. They are doing some checking of the final inspection of the turbine. Various checking they will do, and various measurements. You might have studied about the measurements and metrology part. That it should be very important. Then these are the some turbine cross section. These are the heat exchangers and some welding of the pipe. Welding also different type of welding is there based on the material. What type of welding rod has to be used. All this knowledge is very important in this case, fabrication. Then comes fabrication. We have to do transportation. Transportation also an involved job. You cannot simply transport. There are so many guidelines has to be followed for transporting various large equipments, and it has to follow some rules, and that rules has to be followed. And this item, a large heat exchanger, YouTube heat exchanger, how it is transported. Even the transporting structure design is an important part. You have to design a structure so that the component should not get undue vibration during the transportation, and the component should not get spoiled by the transportation. That is, so transportation is very important. Then installation. So very large component has to be installed in the site, and the site engineer has the responsibility to install the component without damaging the component and without having any accident during this installation. You see the size is very big. This is a 12 diameter pressure vessels that has been installed in our reactor site. So the site engineers are very responsible in this case. So you should know how to handle this. Suppose if you don't know about the importance of that equipment, how you will be able to handle. That means person who is handling this should know the importance of that equipment, what this equipment is used for, how important it has to be safely handled, what way you can handle it, whether it has to be handled in a vertical way, whether we can turn it. Some component we will not be able to turn it. That is not allowed. So the person should know everything about the component. then only he can able to handle that. That's what the knowledge about, again, the full knowledge is required to handle this component. So site engineers, that also mechanical engineers will be playing a major role in this, in the erection of the components. And we can see that in a power plant that how complicated is the various piping system, and most of the piping system will be done at the site itself. So site engineers has to oversee the fabrication activities, erection activities, and after erecting, finally it has to be have a integrated testing. That means none of the welds are failing, none of the places it is leaking. All this testing has to be done by the engineers. These are some of the, even the Kudankulam, I just took the from the net only. Kudankulam, some of the components, this is the reactor pressure vessel, is erection of the reactor pressure vessel. This is the erection of crane. And this is the even the top dome of the Kudankulam nuclear power plant. So here everything, you see how many people are involved. So these all job requirement will be coming when a new power plant is coming. So this many people are responsible for different aspects. So they will be coming here, and with their permission, their supervision only, things can go. Something goes bad, we cannot go back. The whole power project, that project has to be stopped. It is very costly equipment. So again making or again getting that thing is very difficult. So it will make the program itself is not viable. You will not be able to produce a power with cheap. So it is very important to handle this component without any accident and without damaging the component. Similarly, next after installation, testing, everything, operation. The main part is coming as the operation of the power plant. So as I told, this control room engineer has to play a major role. He is basically the brain of the power plant. He should be able to take important decisions while the power plant is operating. So you will get some variation, some signals which may indicate something. So you should know about the entire checklist before starting a power plant, before starting a reactor or a power plant. Various checklist has to be checked. It has to be passed, and then only you can start a power plant from the shutdown condition. So, and during the operation, many signals will be coming. Somewhere temperature showing very high, somewhere some alarm will come. So based on the alarm and the sensor indication, the control room engineer should be able to take decisions. And he is the person who, that means he may have to take quick decisions. And some of the decision he may have to convey with his superior, or he may have to convey with the maintenance people. So he is the person who is doing all this operation. And above that, one senior person, plant engineer, who will be supervising the entire operation from the control room. He will be basically interacting with the control room people as well as the maintenance people. And with his permission only, next action will be taken up. And if the problem is much severe, the higher level authority will come into action, and they, based on their command only, will be taking the further decision on continuing the operation or shutting down the power plant for maintenance. So main aim for a power plant operation is able to run the power plant without any outage. So once you shut down a power plant, lot of crores and crores of rupees per day, that is the your loss. Loss is in crores. 100 crores, 200 crores, like that. Loss is in crores. So we should not allow the power plant for an unwanted shutdown. There are scheduled shutdowns are there for the power plants for taking up various maintenance activities. That is allowed. But unplanned shutdown is not at all allowed, or it will be very costly for a power plant. So the skills of the control room engineer, plant engineer, all the people come very important. That means I was telling in the introduction, experienced people, skilled manpower, very, very important in this type of work. So as we expand the number of power plant, number of nuclear reactors, other reactors, the number of people required in this area is very high. So the skilled manpower we cannot lose, and their growth also will be very good in this. So supervisor, as I told, he will be supervising all these activities. And these are some of the pictures of a nuclear power plant control room. You see so many various information will be coming about various locations. All sensors will be showing things, and many alarms will be set. So there are safety alarms, trip alarms, and many alarms will be set for the safety of the power plant. That means anything going beyond this, the reactor or the power plant has to take its own action, or the control room person has to take action based on the indication he is getting in the control room. So many people will, 4 or 5 people will be working in the control room in shift. And you see, this is the control room of a power plant, and the right hand side is a control room of a nuclear powered submarine. You see how much compact it is. The same thing is now compact way, because we don't have the luxury of large control room like this. We should be able to sit in a very small room and operate the nuclear propelled submarine. So in that way, nuclear powered submarines are operated with the pressurized water reactor, PWR. So this picture shows the submarine of India's first nuclear propelled submarine, that is called INS Arihant. It is the launching of the INS Arihant. This is a nuclear submarine as it. Advantage of this type of submarine is it can go under the sea up to half-kilometer down, and it can be in the sea without any. It need not come again, because it is nuclear power self propelled. It can be beneath the sea for long hours. So that is the advantage of nuclear propelled submarines. So that way, this type of reactors are very important in this defense requirement, also meeting the defense requirement also. Finally, and not least, but very important thing is maintenance of the maintenance engineers. They are the main person who keep the reactors in operation without any shutdown. You have to do a proper preventive maintenance, predictive maintenance, all these aspects. Then only you can, as I told now, you can continue the operation without any uninterrupted shutdown. So they also should be knowledgeable enough to have about the various equipments, their performance, what is the variation in the performance, what it indicates. Based on that, he has to give the indication to the control room people, or based on the control room signal, he should talk with the control room people, and whether the shutdown has to be done or whether it is we can continue the operation. That decision has to be taken in consultation with the maintenance engineers. So they have to play a very important role, and they should be very skillful. Skilled people are very important in this. They should be able to identify the problem and able to rectify the problem at the minimum time. That means if you are finding some problem and you are not skilled enough, or you don't have much experience, what will happen? The reactor will be, or the plant will be under shutdown for a long time, till some skilled person we get from somewhere else, and he comes and identify the issue. Then you rectify that. That means some 1 month might have gone. How much money the power plant person is losing. So he also wants a very skillful people who knows about all the systems, operation, machines, all these things.
Sajish sir. Hello, Sajish sir.
ഞാൻ വിളിക്കുന്നുണ്ട്.
Okay sir, okay.
കട്ടായി പോയി. ഒരു കാര്യം ചെയ്യേ, ചാറ്റ് ബോക്സിലൊന്നും ഇടാവോ?
സർ, അദ്ദേഹത്തിന്റെ നെറ്റ് കട്ടായതാണ്.
ഡിയർ സ്റ്റുഡൻസ്, പ്ലീസ് വെയിറ്റ്. നമുക്ക് സെഷൻസ് തീർക്കാം. 10 minutes കൂടെ ഉള്ളൂ എന്നാണ് പറഞ്ഞത്.
Sajish sir, welcome back.
റെഡി ആയോ?
തിരിച്ച് ജോയിൻ ചെയ്തിട്ടുണ്ട് സാറ്. വേറൊരു ഐഡിയ ജോയിൻ ചെയ്തിരിക്കണേ. Sajish sir, am I audible?
സജീഷിനെ വിളിച്ചിട്ട് കിട്ടുന്നില്ല, ഫോൺ ചെയ്തിട്ട് കിട്ടുന്നില്ല. മറ്റടുത്തായിരിക്കും, ഫോണ് പിള്ളേരത്തായിരിക്കും.
Okay, sir. Sajid sir, welcome back.
Hello.
Yes, sir.
Hello,
yes,
hello.
sir.
I got that long back.
No, you are audible. Your video is okay.
Hello.
ഞാൻ വിളിച്ചോണ്ടിരിക്കുകയായിരുന്നു.
Okay. So I don't know where I lost connection.
Sir, please, that last slide, sir. Please
Okay,
present
okay.
it.
So I just want to tell that. Okay. 1 minute.
Yes, sir. It's visible.
Coming?
Please. Yes, sir. It's coming, sir. Please take the PowerPoint,
Okay.
sir.
So as a summary.
Sir, before that.
Yeah. Operations, maintenance. This you are seeing?
No. Before that, sir.
Oh, this also you are not seeing.
Yes, sir. This one. In between of this. No.
Yeah.
In between this one, we got the connection cut.
This you got seen.
No, sir.
This you are seeing.
Yeah.
This is okay. Next slide.
Next one, sir.
This one. Yeah.
In between of this, it was connection.
Yeah.
Okay. So what I want to say is, after the installation, mainly is the operation of the nuclear power plants. So operation engineer or the control room engineer has to play a major role in this. So they are the brain of the nuclear power plant, where they have to take an important decisions for the continuous operation of the plant. As I told, if the reactor or the power plant gets shut down due to some undue some other issues, a lot of money will be lost. Per day around crores of rupees will be as a loss. So main important things that we should able to take important decision to prevent any unwanted shutdown. So the person in the control room engineer should be skilled enough to take important decision. He could able to understand various signals coming from various sensors, and accordingly he should able to take decisions. Or if he is not able to take decision, he should able to properly communicate with his superior, or he should able to communicate with the maintenance people what action should be taken, whether to continue with the operation, or whether we have to reduce the power production, or we have to shut down the reactor. So this type of things only the control room engineer only can take decision. For that, he should have a good knowledge about the entire operation, entire process of the power plant, and knowledge about the various sensors, what the signal means, what are the various signal indication, what are the alarm means. So these people will be continuously trained department or respective department, and they will get a good exposure to all these things. Every time they will be trained, they will be checked, and they will be again requalified. Then only these people will be posted in this post. That means this is a very responsible post. And in a power plant control room, around 2 to 3 people will be per shift. You know that the power plant is operating in the round the clock basis. So every shift, some people will be there, and after that shift will be changing. So they are the people who is running the power plant 24 into 7 hour basis. And another thing is plant supervisor. It will be higher post, who will be basically interacting with the control room engineers and the maintenance people, and he will be responsible for the entire plant. That maybe 1 or 2 people will be there, and the supervisor will be responsible for the entire plant operation, and he should be able to take decisions based on input from the control room engineer and the maintenance to continue the operation, or various plant management protocols and production control. Everything we will be taking care of. And he is the person who will be preparing the schedule for various operations. First we have to do this like this, and next whether we have to reduce the power, and the power demand is coming down, the peak production is. So there are power plants are operating in the two types of peak load operation and the base load operation. Base load operation power plants will be operating always at the base load and always it will be continued to operate. Peak load operating power stations will vary the power operation based on the demand of the grid. Grid demand comes down, automatically they will also reduce the power production. Accordingly, based on the demand, the power production, the rate of the power production will increase or decrease. So the plant engineer or the supervisor has to take care of all this scheduling of the power production and taking the decision on whether to continue with some case, some some unexpected event happens, whether to continue with the power production or we have to go for an unplanned shutdown. That decision he has to take, or he'll not in a position to take decision. He has to communicate with his superior, that means station director, all that he has to communicate, and based on their input, we have to take decision. So that this operation, that control room engineer and plant engineer, all these have a very important role to play, and these people have to come into this level based on their experience in the working in various positions. And this is some picture of the power plant, the control room of a big thermal power plant, a nuclear power plant. You can see that how spacious it is, and various signals are coming into this. Various signals of various sensors, and it shows the healthiness of various components, various systems, and it gives alarm or some indication about various state of each system. So some alarm comes, it has some meaning. So the person sitting in the control room should immediately understand each alarm and able to take decision on that. So some alarm means that may be simply an indication or some warning signal. So he may have to do some operation which goes, it will nullify that operation or take care of that warning. So he should to attend that warning. In some cases, it may be more important warning. So at that time, he has to communicate with the maintenance person and take action. That means these people who is sitting in the control room has to do a very important job to keep the power plant in a continued operation without letting the power plant to go for an unexpected shutdown. And this right hand side is a control room for a nuclear powered submarine. You see that the size of this control room and this is the size of this control room. There we don't have the luxury of large space. Hello, you can hear?
Yes, sir.
Okay. So here we don't have the luxury of large space because the space available is very small. Because when their power plant is a very compact power plant, and you have to sit here, and you may be working under the sea for many months. So this advantage of nuclear powered submarines is that you can be in the sea up to half kilometer depth for many months without coming up, without even being detected. That much strategic operations this can be done by nuclear submarines. So this picture is the India's first nuclear powered submarine, INS Arihant. It is launched, I think, 2 years back, and it is in the Visakhapatnam in the launching time. And this is a typical nuclear powered submarine in the near the sea. So that means these power plants, nuclear power plants, not only provide the power, it also help to propel various defense application also. So that way, different sizes of power plants help for meeting not only energy demand for the various strategic application. Next comes the important job, that is final job and the very important job, mechanical maintenance of the nuclear power plant equipments. Here, the maintenance engineer should be very knowledgeable, very skillful, and able to take or understand the problem in a quick way. Once some problem comes in a power plant, immediately these people will be sought and they have to answer, they have to attend the problem, and your skill will help to identify the problem very easily. If you are more skillful, you will be able to understand the problem, able to rectify the problem within a short time. That means you are saving crores of rupees for the power plant. Suppose you are not skilled enough or you are not knowledgeable enough, that means you may have to shut down the power plant and look for some other knowledge base from outside. By the time he came, 2-3 weeks or 1 month might have gone. You see the how much money has lost for the power plant operator. So he always have tried to keep a set of very skillful maintenance people who have in-depth knowledge about various systems, equipments, and how the equipments are working, and some signals coming from that, whether what it means. Suppose we know that if you are a skillful person, by hearing the sound itself, they will be able to understand what is the problem, whether it needs an urgent maintenance or it can go for till the next plant shutdown. So that decision the maintenance people only have to take, and they have to communicate with the control room engineers more effectively, and help in plant superintendent to take decision on the continue the operation or shut down the plant. So they are very important people for a power plant. So this comes from your experience, your knowledge about the subject, and your dedication towards the work. So that way, maintenance engineers contribute a large to a power plant operation. So this is the similarly final stage is the decommission. Anyway, we need not talk about that now. So this forms a sequence of operation in a power plant and their importance. And as I told, there is a large requirement for all these areas. People are present situation is people are not available who are skilled enough or knowledgeable enough. So knowing the subject, people who can take decisions, who can perform very well, that type of people are very much in demand. So be thorough with your subject, and it is going to come a large demand for various positions like this, because as I told, power production is going to increase many folds. That what going to come in by 2035, and I told 7 times, 8 times number of power plants has to increase, and we need skilled manpower. Definitely, you are in high demand who are having completed diploma or degree in a very flying colors. They will be definitely get position in these industries. That's what I want to tell. So in a summary, as I told, the energy consumption is a key indicator for our development or growth. A country which is aspiring to become a global power or a developed country, you need proportionately there is a increase in energy consumption. Consumption should be there. So present, that means the power projection as per the Niti Aayog, we need around 7 to 8 times of the power what we are producing now by 2040 and 2050. That means proportionately we have to increase the power production, means we need that many number of power plants. That means number of power plants going to come in next 20 years is 7 to 8 times than the number what is available now. In that one, major portion is coming from the coal and nuclear energy. So coal, as I told, there are new technologies going to be under development, that is ultra supercritical power plants, and it is going to be launched very soon, and various locations it will be starting. And now government of India has sanctioned around 10 nuclear power plants and various locations of the country, and Nuclear Power Corporation of India is now in the launching the starting the work for this. And as came to know from the top people from NPCIL, that there is a huge demand for the people in the diploma in mechanical, degree in mechanical, and huge demand, and they are looking for people having good understanding of the subject, so that they can put them with minimum training into the site directly on the job. So they will be definitely looking for the people, and there is a huge shortage of manpower in this area. They want people having these skills, knowledge, the diploma level, in the degree level. That means the future is very bright for the people who are just now passing out from the college or degree and the diploma. So only thing is you should be very thorough with your subject, and you should prepare yourself to face any of these questions, any of the thing what I have explained, so that you can prove yourself you are suitable for this job, and definitely you will be placed in one of these areas, not only in the hard mechanical industry, any industry. If you are looking for software, any places, as I told, no, India is going to develop in a major way. So opportunities are very huge. So in that way, I wish all the people may get immediately job immediately after finishing their degree diploma. So thank you for a patient hearing.
Okay, sir. Thank you so much. Then ഏറ്റവും സന്തോഷമുള്ളത് സാർ ഇത്രയധികം അവേഴ്സ് ഓഫ് ലേബർ ഇതിനു വേണ്ടി പ്രിപ്പയർ ചെയ്തിട്ട് ഒരു 2.5 മണിക്കൂർ ഞങ്ങളുടെ സ്റ്റുഡൻസിന് വേണ്ടി വളരെ ഡീറ്റെയിൽഡ് ആയിട്ട് ഈ ഒരു ഡെലിവറി നടത്തി. ഒരു ടീച്ചർക്ക് വരെ ഇത്ര എന്തൂസിയാസ്റ്റിക് ആയിട്ട് ഇത്ര ഡീറ്റെയിൽഡ് ആയിട്ട് ചെയ്യണമെങ്കിൽ അത്രമാത്രം അവര് കമ്മിറ്റഡ് ആയിരിക്കണം. അപ്പോൾ സാറിനോട് പ്രത്യേകിച്ചൊന്ന് റിമാർക്കബിൾ ആയിട്ടുള്ള രീതിയിൽ അത് നന്ദി പറയാണ്. ഇനി അടുത്തൊരു കാര്യം സ്റ്റുഡൻസ് ശ്രദ്ധിക്കേണ്ടത്, നമുക്ക് ഈ ഒരു ടോപ്പിക്കില് നിങ്ങൾ നോക്കിക്കോളൂ, യൂട്യൂബില് പൊതുവെ ഒരു റഫറൻസ് മെറ്റീരിയൽ ഉണ്ടാവില്ല അല്ലെ. സാറിന്റെ ഈ ടോപ്പിക്കില് ഒരു റഫറൻസ് മെറ്റീരിയൽ ആണ് സാറ് നമുക്ക് തന്നിരിക്കുന്നത്. അപ്പോൾ നമ്മുടെ ഈ ഒരു വീഡിയോ നമ്മൾ എഡിറ്റ് ചെയ്തിട്ട് എന്തായാലും അപ്ലോഡ് ചെയ്യും. കാരണം ഒരു പവർ പ്ലാന്റിന്റെ ടോട്ടൽ ലെവലിൽ നിങ്ങൾക്ക് എന്തൊക്കെ റോളുകളുണ്ട്, ആ ഓപ്പർച്യൂണിറ്റീസിൽ നിങ്ങൾ പ്രിപ്പയർ ചെയ്യുമ്പോൾ എന്തൊക്കെ ഒരു സബ്ജക്റ്റ് ഏരിയ ആണ് നിങ്ങൾ വളരെ സ്ട്രോങ് ഹോൾഡ് ആയിട്ട് വെക്കേണ്ടത് എന്നുള്ളതിന്റെ ഒരു റഫറൻസ് ആണ് സാറ് സ്റ്റുഡൻസിന് മാത്രമല്ല ഫാക്കൽറ്റിക്ക് വേണ്ടി പ്രസന്റ് ചെയ്തത്. അതിന്റെ ഒരു വാല്യൂ നമുക്കത് എത്ര അധികം വിലമതിക്കാൻ സാധിക്കാത്ത ഒരു കാര്യം തന്നെയാണ് കേട്ടോ. അപ്പൊ എന്തായാലും നിങ്ങളുടെ ഫീഡ്ബാക്സ് പറയാനും പിന്നെ നിങ്ങളുടെ ക്വറീസ് ഉണ്ടെങ്കിൽ അത് ചോദിക്കാനുമായിട്ട് സ്റ്റുഡൻസിനെ ക്ഷണിക്കുന്നു.
എന്ത് വേണമെങ്കിലും ചോദിക്കാം. നമുക്ക് അറിയുന്നതാണെങ്കിൽ നമുക്ക് ആൻസർ ചെയ്യാൻ പറ്റും, അല്ലെങ്കിൽ ഞാൻ ചെക്ക് ചെയ്തിട്ട് കമ്മ്യൂണിക്കേറ്റ് ചെയ്യാം. എല്ലാം നമുക്ക് അറിയണമെന്നില്ല. സ്റ്റുഡൻസ് ജനറലി റിലക്റ്റന്റ് ആണ്.
നിങ്ങളുടെ സെഷനെ കുറിച്ചിട്ടുള്ള ഫീഡ്ബാക്സും നിങ്ങൾക്ക് ഇതിന്റെ ഒപ്പം തന്നെ പറയാം കേട്ടോ. ഫീഡ്ബാക്സ് പറയാം, പിന്നെ ക്വറീസ് എന്തെങ്കിലും ഉണ്ടെങ്കിൽ ചോദിക്കാം.
സജീഷ്, എനിക്കൊരു ഡൗട്ട്. I'm not an expert in this area. And how the nuclear power plant is immersed in the sea, or how it is held in the sea?
Actually, nuclear power plant, it is like you are keeping some power plant in a ship. You make a modular reactor, as I told. Now, in future, the idea is make power plant as small as possible. Even we will be able to keep it in a thickly populated city, or keep it. There are one floating reactor Russia has developed, but I think I forgot the picture. There is a floating reactor. What they are telling, where the very difficult to construct some reactor in the Arctic regions, they'll take this reactor nearby to that wherever possible, then power to the remote areas. So it is possible to construct a reactor in a bed, like a large ship you can construct, and it is operate like a normal. You can see that in a ship itself, there are a lot of systems, all the cooling system. So balance of power plant already is there in the ship. Generator, everything is there. Only that nuclear part only you have to replace it with that. There it may be a diesel generator. In a ship, if you see the energy is generated from a diesel generator, further cooling, circuit, conversion, everything is there. So their source is a diesel generator. Instead of a diesel generator, we will be keeping a nuclear power plant. That will be very compact. That is happening in the submarines. That's what I shown. In submarines, there will be a compact pressurized water reactor. It will be kept there. That will be powering the entire submarine, and it can be under the sea for long months, many months, even without get detected.
Okay. Students, you can ask questions, please.
Sir, my name is Tito. I want to ask you a question about a nuclear power plant. So that a lot of wastes are like radiations are produced in nuclear power plant. So that how they can be disposed.
See, radiations no need to dispose. Only issue with nuclear power plants is disposing of the spent fuel. That means the fuel which after using in the reactor has to be taken out. That have highly radioactive. This fuel, spent fuel, are highly radioactive. This has to be disposed in a safe place. That what we will be doing is we will take the fuel and keep it the fuel under the water. Water is a very good shield for the radiation. So we'll keep it in a water pool around 8-meter height. We keep the spent fuel for a long time, even up to 2 years, 3 years. Then in India we have a program recycling the spent fuel. We will take up this spent fuel. After that, after 2 years, the radioactivity level might have come down, so that you can operate with that. We will take out this spent fuel and send it for reprocessing. Reprocessing means we will cut the fuel, chop it, and put it in some solution. And what we will do is, basically, as I didn't tell about that, uranium is the main fuel in a nuclear reactor. The uranium, if you take a uranium material out of this 99% is uranium-238. Remaining only uranium-235, which is fissile. That means it can undergo fission. That is called fissile. Remaining is fertile material. What will happen when we keep this uranium? Uranium-238 will be converted to plutonium-239. Hello? Yeah. Can you hear?
Yes, sir.
Hello?
Yes, sir.
So uranium, that is fertile material, will be converted to a fissile material that is called plutonium-239. So during this separation process, what we will do is we will separate the fissile material from this. Lot of uranium-238 might have converted to plutonium-239. This is a strategic material. So strategic in the same terms, we can use it for many purposes. We can use it for making nuclear bombs. You can make it using in the next nuclear power plant also. So as India is concerned, we need both for strategic purpose and for future nuclear application. We need plutonium-239. So we will separate it, the plutonium-239, keep it safe, and remaining things. Then finally it will become very small. It will be. Then there is a process called glassification. We will glassify this whole thing, make like a glass cube. The whole thing will be a small glass cube, and kept it in a container, very thick container, a container with a lead shield container, so that no radiation should come out. Even if you keep it in the public place as well, there should not be any radiation. That way we have to design a container, keep all the material inside, and put it in underground storage facility. That will be for years. One advantage is there. Finally, after this processing, it will be small cube. So after many years only, you will have very large fissile material, spent fuel, which has to be further disposed in a underground storage, like some old mines. That is, people are thinking in old mines they will be putting in, and it is be closed. That is the only issue with the nuclear power plants. Handling the spent fuel things.
Okay.
Any other? But otherwise, normal operation, there is no radiation. We have radiation protection like lead shielding, concrete shielding, water column. Water is a very good shielding material. If you have some 2 meter thick water, almost all the radiation will be absorbed in the water. Then concrete shielding will be there. That means after that, outside if you stand, you will not be getting any radiation. Any other question? I hope I have answered.
Yeah. Any feedback, Sajish sir?
Yeah.
Definitely. Students are open to give the feedback.
Yes. Speed is little high because last few slides I just rushed through. Maybe time was. Because when we prepare, we won't have much idea because it's a topic I have not presented anywhere. No? So first, Pradeep gave me an idea. He wants this. That's why I was preparing in that angle. What the students can benefit in that future job prospects. That way only I prepared, not like a subject. So he wanted that way. So I hope I could able to.
Actually, this is for the first time Sajish addressing mechanical based diploma students, and it will be an asset for our side because your PPT and your YouTube will be useful for it. It will communicate to our students and we invite you you have to from the college team. Short.
I think they can see this presentation itself.
No, but you can polish your slides. In each and every sessions.
Yes. Thank you. Anyway, I am very.
You can improve your slides also.
Yeah. Every time we feel that okay, this would have been modified like this. That feedback ourselves we will get while we presenting, because when we make slides, we don't know how much time it will go, where it will take. Initially, we think it may take only 1 hour, but finally it will end up in 2 hours. That way.
Okay.
Okay,
So
sir.
anyway,
Yes, sir. Yes, sir.
I
Yes,
am
sir.
very thankful for Pradeep and other colleagues in the your institute, Chelakkara and Perinthalmanna, for giving me an opportunity at least to share some of my thoughts, or maybe it may not be very clear. Also, maybe some, if you can get some idea, I will be very happy on that.
Sir,
We got a lot of information related to this nuclear power plant, and also you have started with the basics or the
Yeah,
history. Okay, then different types of power plants are there. The students get a clear cut idea about the different stages or different types of uh, power plants, including nuclear power plants. Okay,
yes,
thank you, Sajish. Thank you for attending. Thank you for giving a session for us. Actually, we are very much thankful to you.
thank you
yes,
Thank
very
you.
sir.
much. Thank
Yes,
you,
sir.
thanks, sir.
As I will for students and faculty in the days to come. So we afterwards, when we are uploading the video on YouTube, Sajeev sir itself will see how many views are there in that particular video. Now I
Okay.
request Vishnu sir, lecturer of Government Polytechnic College, Chelakkara, to give at least a formal type of vote of thanks. Sir, Vishnu sir, please.
Hello.
Yes, sir. You are audible, sir.
Yes.
Respected Sajish sir, Head of Structural Dynamic Section, IGCAR Kalpakkam. Respected Pradeep sir, HOD and Principal in charge of GPTC Perinthalmanna. Sajid sir, Lecturer in Mechanical, GPTC Chelakkara. And other faculties and dear students. So today we had an excellent session by Sajish sir on the topic of power plant and especially related to nuclear power plant. Started with the history of power plant and then went up to how an engineer or diploma holder should uh, develop to be an employee in this particular field. So sir give the way power plant and vacancy and students practice in sense in this particular process. So give sir for giving this much details and guidance to our students in their future, for their future. And there was a great opportunity for students to ask more questions, but only very few, one or two students came forward. Only one student came forward to ask questions. It was a great opportunity, and you will not get such type of